Hey guys, I hope you're doing great today. This is our chapter number 29 of our DevOps Roadmap 2024, in which we are going to learn about Terraform. So guys, so far our DevOps journey have been great so far, right? We have discussed, we have learned how to use Linux. We installed Linux and we executed 75 plus commands that are helpful for DevOps engineers on Ubuntu VM, right? We installed a local VM machine on our personal computer. All those tutorials have been uploaded on my DevOps Roadmap 2024 playlist. So you can stick with this playlist so that you have a clear picture how we are moving with our DevOps roadmap. So Linux was the basic thing. Linux operating system should be your base to learn about DevOps tools, because on the very first day I told you that all DevOps tools run on Linux. Okay, so we discussed about Linux, we discussed the file system of Linux operating system and directory structure, and after that we started with Docker and we learned about Docker, and after that we discussed Git, version control and 50 plus Git commands. And also after that there is a playlist for CI/CD tutorials as well, in which we discussed about CI/CD, continuous integration, continuous deployment, and how we can spin up a pipeline on GitHub Actions. There would be more CI/CD tutorials coming along. So guys, don't worry, we are not done yet with CI/CD, because Terraform also is an important part of CI/CD, because it is related with infrastructure automation. So Terraform is actually our fourth DevOps tool. So we have covered Docker, Git, CI/CD, and now Terraform. And you saw that these all tools run on Linux. So I hope that now you have a clear picture how we are moving along with our DevOps journey. So I am super excited that we are starting with Terraform today, because Terraform is one of the most important DevOps tools that is almost demanded in every DevOps job. So it is, I would say that, mandatory to learn about Terraform. So that is our actually 29th chapter. I'm really excited that we have covered almost 28 chapters, and I have been getting so much questions and I'm trying to answer each one of your questions. So make sure that you subscribe DevOps Molvi on YouTube, and we are going to further with Kubernetes, Ansible, and also ELK as well. So this playlist is actually restricted for DevOps tools. And also I have created a separate playlist for Google Cloud Platform. After all, we have to move towards cloud. So it is also mandatory to learn at least one cloud. And we have started with Google Cloud Platform. So you might have seen some lectures, 2 chapters we have covered so far. And we are going to discuss more about Google Cloud Platform. So that is actually a separate playlist, so I don't want to mess up DevOps journey. So that's why I have created separate playlist for Google Cloud Platform, and we are already in DevOps roadmap playlist. I will share the links of these playlists so that you have a clear picture that this path leads to cloud platform, and this is that we already have been covering so far is to DevOps roadmap. Let's get started. In this introductory lecture on Terraform, we are going to discuss Terraform from 6 aspects. So first of all, after all, we know Terraform is an infrastructure as code tool, but what is infrastructure as code? What do we mean by infrastructure as code, IAC? So we will discuss it first, IAC, so that we know, because Terraform is not the only IAC tool, infrastructure as code tool. There are other infrastructure as code tools as well. So first we need to understand what is infrastructure as code. Number 2, what is Terraform? Number 3, why do we need Terraform? After all, why? What is the purpose of Terraform? What are the benefits of Terraform? How Terraform supports automation? What is the role of Terraform in infrastructure provisioning, in infrastructure automation, or we can say in infrastructure creation? Number 4, what are Terraform providers? Number 5, what are Terraform plugins? And the last one is, what are Terraform modules? So these are actually, you can say these are interview questions and answers as well regarding Terraform. So when you are going for a DevOps engineer, you can expect, because this is one of the most frequently asked question, that what are Terraform modules, what are Terraform providers. So these are important DevOps interview questions as well from infrastructure provisioning point of view. So let's get started with infrastructure as code. That would be our first topic. IAC stands for infrastructure as code. So let me share it with a very common scenario that we need infrastructure to run our applications. Am I right? Yeah. Because our applications run on servers, our applications need network, our applications need databases, our application need load balancers. So that is all infrastructure that we should have to run our applications smoothly. We have to provision infrastructure, and that was the practice before that. We have to do it manually. There was no automated process to provision infrastructure. We have to manually set up servers in the data centers or in the on-prem data centers. So that was actually the traditional way to prepare the infrastructure. I have to set up my Linux server. I have to set up the network for my Linux server so that my application runs on that Linux server. So that was actually the traditional and manual way. Now in infrastructure as code, we don't have to worry about the manual installations, manual configuration, or manual provisioning of our infrastructure. That is fully automated, and we just need to have configuration files, which are known as, by the way, .tf files in Terraform. So we will need those configuration files, and with the help of those configuration files, which contain every information regarding our infrastructure, and we can use those configuration files to spin up our infrastructure for one time, for two times, for multiple times. So it is possible using those configuration files to provision our infrastructure. There should be a question in your mind that we have those configuration files, and what kind of language these configuration files use. So these configuration files use declarative language, in which every information regarding our infrastructure is saved. And there should be another question in your mind: what if we update infrastructure? What if we add more servers in our infrastructure? So it is easy to update these configuration files, and in Terraform it is HCL, HashiCorp Configuration Language. So we can use this language to write infrastructure files, and by running those infrastructure.tf files, we can provision infrastructure using Terraform. So I hope that now you have a clear picture that how we can use infrastructure as code to provision infrastructure automatically. And using Terraform, we will write .tf files like main.tf, variables.tf, and each tf file, .terraform file, is written in HCL, HashiCorp Configuration Language, and it is also a syntax-based language, just like YAML. Okay, we discussed YAML in CI/CD and also in Docker Compose. So it is also a syntax-based language which is easy to read and write for humans. And this HCL or HashiCorp Configuration Language, which is a declarative language, and it is used to write Terraform files, and those Terraform files are used to provision infrastructure. And now let's discuss our second point, which is what is Terraform. So what is Terraform? Terraform is an infrastructure provisioning tool which is used to build, change, and also version. We will have different version of our infrastructure, and Terraform is used to build, change, and version our infrastructure safely and efficiently. So we must address this query as well, that what kind of infrastructure we can build using Terraform, whether it is only specific or limited to small infrastructures like VMs or load balancers or storage buckets. No, Terraform is used to build small infrastructure, like we can also build VMs, we can also build storage buckets, we can also build security groups or firewall rules using Terraform, but also we can build complex infrastructure like DNS servers, virtual private clouds, software as a service entries, and also complex networking infrastructure using Terraform. So now let's talk about how Terraform works. So in Terraform, we have configuration files, like this one is main.tf. So we can create one Terraform configuration file, main.tf, and we can have everything in that file, but this would actually make the file complex. So the best practice is to create separate files, like we used to create variables.tf, firewall.tf for firewall rules, network.tf for networks, vpc.tf for virtual private cloud. We will have our lab sessions and we will discuss how we can have one single main.tf file, or how we can have all the files separately, and then we can also provision our infrastructure using all those files at one time. So main.tf, this file actually contains every information regarding our resources, regarding our providers, the information about provider, what kind of provider we are using. We are going to discuss in our next point: providers, resources, network interfaces. Now resources can have firewall rules, VMs, storage buckets, etc. And we will have our variables. So all of these resources, providers, plugins, Terraform version, network interfaces, variables can be included in a single main.tf file. But the best practice is to create separate .tf files in which we can have a provider.tf, resources.tf, interfaces.tf, or variables.tf, and then this would make us easy to understand the infrastructure. Okay, we can go through variables to find all the details of variables and which variables are being used. We can have a quick look on resources.tf, in which we have the information about our resources like VMs, like storage buckets, load balancers, firewall rules, and similarly we can have a single provider.tf file in which we can mention the provider like Google, AWS, Azure. So let's suppose we have a simple infrastructure in which we have to provision one VM with a boot disk and an interface or network. So we can have all of that information about provider, resources, VM, network interface. So we can have the variables information like the zone of the VM, size of the VM like E2 micro or E2 medium. So everything can be included in this single file. So just to provision, that would be actually our first lab, in which we are going to use only one main.tf file, and we are going to provision one simple VM in the cloud using provider as Google, AWS, or Azure. Resource would be our VM, and there would be one network interface so that we can access our VM, and the variables would be the zone, the region, and so on. So that's how we can use this configuration file to provision our infrastructure. And these configuration files can be complex to provision large infrastructures, like I told you how we can build a full load balancer or VPC or DNS server using Terraform, and it is possible. But we are going to start with provisioning VMs, storage buckets, firewall rules, and network interfaces, boot disk in our lab sessions. So guys, that's how Terraform works. We have .tf files, and those .tf files are syntax based in HCL HashiCorp configuration language, and those Terraform TF files are used to provision infrastructure. And in our next lab, we are going to provision one VM, and you will see, we will discuss together how the syntax of Terraform works, how we can write the .tf file to provision infrastructure in Terraform. So guys, we need to have a clear understanding of the .tf files, the infrastructure, the Terraform infrastructure files, and their extension is .tf. So that would be our next session. And now our third topic was, why should we use Terraform? What is the purpose of Terraform? And I have already answered this question in the beginning, that Terraform helps us to automate the process of infrastructure. It speeds up the automation process of our infrastructure provisioning. We can build, we can even destroy our infrastructure if we don't need it. So that is actually the key purpose of Terraform. And then we also have the whole information about infrastructure. We can easily navigate through the configuration files, which are .tf files of Terraform, and we can have a clear picture of our infrastructure. What do we are running at the moment, how many storage buckets, how many VMs we have, what is the provider, whether we have our infrastructure on Google, and also we can update, we can downgrade our infrastructure. What do we mean by upgrading the infrastructure? That's how we can explain it. I have an E2 micro VM. It can be easily updated to E2 medium. So we can also use Terraform to update our infrastructure, to change our infrastructure. And when we don't need that VMs, we don't need those storage buckets, we can use Terraform destroy, which is a Terraform command to destroy everything, and it will remove the infrastructure. But our configuration files and our infrastructure files would be saved, and we can use these files to spin up or to build our infrastructure again. So it definitely reduces the cost. It definitely reduces the overhead of building new infrastructure. We have files, we have infrastructure information. We just need to run a couple of commands, and we have our infrastructure up and running in a couple of minutes. So that is actually the key benefits of Terraform. Now, our fourth topic is, what are Terraform providers? So the providers are actually Terraform plugins that are used to manage resources. That is actually the simple definition. Providers are Terraform plugins, and using these providers, Terraform providers, we can manage our resources. And from resources, what do we mean by resources? VMs, storage buckets, load balancers, network security groups, firewall rules. All these resources can be managed using the Terraform providers. And Terraform providers are actually Terraform plugins. In other words, a Terraform provider is a plugin which has an API, and that API is actually used to communicate with the cloud provider. For instance, now let me explain it, how we can use a Terraform provider. We have this provider.tf file, okay, and in which I am using provider as AWS, okay. Now AWS Provider is available in Terraform registry. It is an official provider, and now I am using this provider, so our Terraform will use the APIs and datasets of this provider. Now it is also used as plugin, and this will use an API to create or manage resources on our AWS cloud. Similarly, you can replace provider with Google. Similarly, you can also replace provider with Azure. We have official providers, official plugins on Terraform registry, and these providers are officially verified by Terraform, and we can use them to provision infrastructure on the cloud platform that I want to use. So for instance, if I want to provision infrastructure on AWS, Amazon Web Services, then I will use provider as AWS, and it will use the API calls to manage resources on AWS. I hope that now you understand what is the purpose of provider, that it is a plugin to manage resources on the cloud using the API calls. Now, for instance, if I want to build a VM and EC2 instance on AWS, I would have to use provider as AWS, and then this provider or plugin AWS will use API to build and manage EC2 VMs on AWS. We can use Terraform destroy, and our EC2 VMs would be deleted from AWS using API calls. So that is actually the purpose of providers. These are plugins to manage resources on the cloud. It can be AWS, it can be Azure or HashiCorp Cloud or even Google Cloud, and we can use providers accordingly as per our infrastructure. For instance, if I am using AWS, I have to use provider as AWS. If I am using Google Cloud Platform, my provider should be provider as Google. So I hope now you have a clear picture of Terraform providers. Now let's move towards our fifth topic, which is Terraform modules. Okay, so what are Terraform modules? If we have a simple small infrastructure, it would be definitely easy to manage it. We can manage it with a single folder or directory. Okay, we can have everything in that single directory, main.tf, provider.tf or variables.tf. But what for the large infrastructure? If our infrastructure grows, then it becomes tougher and tougher to manage the whole infrastructure in a single directory. So what do? We create separate directories, we create separate folders, and those directories are known as Terraform modules. For instance, if I have this main directory, okay, and then I create subdirectories as this is, for instance, server, and it contains servers.tf, okay, and every information regarding servers. So now this is a Terraform module. Similarly, we have as buckets. Now this is a Terraform module, and then we have our network like firewall rules or VPCs, etc. So now these are actually Terraform modules, and these are actually child module, and this is the parent module, root, known as root module, and these are known as child modules. So every configuration file regarding servers would be in the servers directory, then this is a Terraform module, and all the configuration files regarding storage buckets would be in the buckets directory. This is a module. Every information, every configuration.tf file regarding network would be in the network directory, then this is actually a a Terraform module. Now, this actually simplifies to understand the infrastructure. Now, everything in a single folder. It does not mean that our infrastructure cannot be provisioned, but it would be definitely difficult and tougher to understand how our infrastructure works. So we create separate folders. Now I have a clear picture that my infrastructure having servers are in the servers directory. Similarly for buckets, networks, load balancers, and so on. Firewall rules. So these are actually the Terraform modules. And then we have child modules, we have root modules. Those child modules come under one root module. So guys, that's how Terraform modules work. We will have a second lab session in which we will have a separate servers module, separate buckets module, and network module, and we can use these separate directories that are inherited by the parent module or parent root module, and we can provision infrastructure. So that is actually the basic and general and clear overview of Terraform modules. The configuration files regarding a single resource together in a folder is known as a Terraform module. Alright guys, the number 6th and last point of our Terraform introductory lecture is Terraform plugins. Just like we discussed about Terraform providers, Terraform plugins are written in Go language. And there is no big difference between the Terraform providers or Terraform plugins. All the providers used in Terraform are known as Terraform plugins as well. So I have already explained the example of AWS provider. So in order to understand Terraform plugins real quick, you can see this diagram. And I have this main.tf file, Terraform file, which contains an information about provisioning a VM on AWS. So I will definitely use provider as AWS, right? When I will run the Terraform init command, this would be the first command we will use to provision infrastructure. The Terraform init command will initialize a working directory which contains the configuration files in a directory, and this directory will also contain the information about plugins. So when I run Terraform init command, this command will go through this main.tf file and it will go through the provider. For instance, if my provider is AWS, then this command will install the plugins, configuration files, and everything that is needed to provision a VM on AWS. So that is actually the role of plugin, that those plugins contain APIs and binaries that are required to provision infrastructure. And when we run Terraform init, those plugins are automatically installed in that directory where our configuration files are. And then after we have those plugins installed, those plugins help us to provision, to run, to build, to destroy infrastructure on our cloud providers. So that is actually the purpose of Terraform plugins. Terraform plugins help us to make API calls. Terraform plugins help us to authenticate between our Terraform and our cloud providers. After all, how we can authenticate our Terraform modules, configuration files with our cloud providers, that's where the Terraform plugins play their role. So we can say that Terraform plugins are the good guys which make possible the infrastructure provisioning process. And guys, don't worry, when we are going to practically run Terraform init, Terraform plan, Terraform apply, all these Terraform commands, we will revise these concepts. We will see how plugins work. We will also see what kind of plugins we can use in our Terraform configuration files. So that was actually a beginner tutorial for Terraform, in which we discussed what is infrastructure as code, what is Terraform, what are the benefits of Terraform, how Terraform improves and speeds up the infrastructure automation process, what are Terraform providers, what are Terraform plugins, and how we can use Terraform to run our infrastructure. And also we discussed about Terraform modules. Guys, one of the most important topics in Terraform is actually Terraform modules. So all of that would also be revised. We will also discuss it in our lab sessions. Make sure that you subscribe DevOps Molvi on YouTube. I will see you in our next Terraform lab, in which we are going to install Terraform on Ubuntu VM. Also, we are going to build and provision our first VM on the cloud. So I will see you in the next video. Make sure to subscribe. Thank you so much for your support. Have a good one and bye. Hey guys, I hope you're doing great today. Guys, this is our second chapter of our Terraform series. In the first chapter, we discussed what is infrastructure as code, what is Terraform used for. We also have a quick look of Terraform providers, Terraform modules, and Terraform plugins. I hope that you remember all those concepts, and if you have not watched that video, make sure that it is on my YouTube channel so you can watch it and make your Terraform concept more strong. So in this chapter today, we are going to build and provision our first VM on Azure cloud. Okay, and this is our second lecture on Terraform, and we are going to practically see how Terraform works, what are the configuration files, or how a Terraform configuration file .tf file looks like. So we will also discuss the source code blocks in a Terraform file, and make sure that you subscribe my channel DevOps Molvi. I really need your support and I appreciate your support so far. So this would be our second lecture on Terraform, and let's get started. So guys, for your convenience, I have created this full-fledged Terraform repository for you guys, especially for you guys on GitHub. So these are actually nodes. It will contain the configuration files we work during our lab sessions, and how we can install Terraform, what are the other concepts or other Terraform commands. Everything we discussed in our lecture, I will make sure that we have that on this repository, and I will definitely share the link, the URL of this repository in the description. I have been sharing all the repository links in the description for the videos I have uploaded on my channel so far. So make sure that you must check out the description section. Most of the videos are uploaded with their respective timestamps, so that you can find the exact thing you're looking for, and it will save your time. And also I have been sharing the repository links, URLs of my GitHub account. This is actually my personal account, but I have been publicly sharing all these repositories as notes for your future understanding, for your future convenience. So this would be our full-fledged Terraform repository, and I have named it as Terraform by DevOps Molvi. So DevOps Molvi is everywhere. I'm sorry for that. I'm not sure what you think about it, but DevOps Molvi should be everywhere, in every GitHub or Terraform or on Docker and so on. So this would be the configuration file of Terraform, but before that, we have to know whether Terraform is installed on our VM or not. So make sure, again, I request you to subscribe, and this would be our second chapter on Terraform. So I will close it. Now I have this VM that I have created on Azure. So let's check the release of this VM, and it is actually Ubuntu 20.04. So Terraform, you can see that Terraform is not installed, and the method or the tutorial or the how-to guide of Terraform is literally very simple, and you can have your eyes shut and you can just blindly execute those commands, and those commands work as a charm. And I have also pasted all those commands and shared the full guide here quickly. Okay, so there are only 5 steps and we can have our Terraform installed. So I actually intentionally didn't install Terraform before, so I thought that we should together do whatever we do, right? So let's see how we can install Terraform. And I have this DevOps Molvi user, and it is a sudo user. And in the first step, we will install the system and dependencies that you have installed in Docker, and you will install in Kubernetes, you will install in CI/CD tools as well. So these are actually the dependencies that are additional packages, and most of the times these packages are already installed. You can see curl is installed, GNU PG is also installed, and also software properties common is installed, but our Terraform is not installed. In the second step, we are going to add the HashiCorp GPG key. Guys, Terraform is the product of HashiCorp. And in the first lesson, we discussed quickly about what is HashiCorp. HashiCorp is actually the Terraform provider. Terraform is the product of HashiCorp, and that's why Terraform is written in HCL, HashiCorp Configuration Language. So we will have the official package on HashiCorp and we have to get it from there. So this key is actually used for the repository, so that these are some additional steps we have to do. And okay, so after that I will add the official repository for Linux, and it is also given by HashiCorp, and we just need to copy and paste the commands, and we will have the HashiCorp repository added in our Linux VM. So these are just copy paste commands, right? That I have shared. Once we add the keys and repository, we have to update the system. So these are actually the practices that should be on your fingertips. Now we will install Terraform. Okay, this is actually the command to install Terraform. So this practice will actually install the latest version of Terraform. So guys, that was the game, and Terraform is installed on our VM. Okay, now you can see we can view all the commands, and don't worry, we will discuss every command that is here on Terraform. Most of the commands that are known as the main commands, we will definitely use most of these commands, like Terraform init to initialize your working directory. For other commands, Terraform validate, check whether the configuration is valid. It will go through the Terraform configuration files. Terraform plan, before we apply, before we build our infrastructure, we can see the plan. The whole plan will show what we are going to build, and that's how we can apply the configurations. And we can also auto approve as well, create or update infrastructure. So these are actually the most famous, the most common Terraform commands that you must know while working on Terraform, because we will most of the time use these commands to build or even destroy our infrastructure. So this is actually the dangerous command, and it will destroy everything we build using the Terraform apply command. So we will use these commands in this lecture as well. So guys, we have Terraform installed. Okay, now what? Now we are going to build our infrastructure on Azure. So I have this Azure configuration file, but before that we must have Azure CLI on our VM as well, because we are going to, you can say, integrate. This is also how our Terraform knows I have to build infrastructure on Azure. How Terraform knows I have to build infrastructure on Google or AWS platforms. So we have this Azure CLI. Since we are going to provision infrastructure or our virtual machine, which is infrastructure, since we are going to provision our first virtual machine on Azure, we have to tell our Terraform that you have everything set for Azure, you have everything set up for Azure, and now you are going to build a VM for us on Azure. So we have to prepare the environment where our Terraform can easily talk to our Azure account. So this is actually my Azure account. So I have this, my personal account on Microsoft Azure, and we are going to install the CLI on our Linux machine. Our Linux machine does not know where our account is hosted on Azure, and it does not have any access keys, subscription ID, client ID, tenant ID, password, nothing. So we are going to first set up Azure CLI so that our configuration file, so that our Terraform can talk to our Microsoft Azure account, and that's why this is actually the mandatory step. And when we will have Azure CLI, we are going to create a principal, and that principal is used in our main.tf file, which is azure.tf file, so that we can provision our infrastructure on Azure. Let's do this drill step by step. So first of all, we have to install our Azure CLI, and this is also a 5 or 6 commands tutorial, and you can find it on my repository in azure-cli.md. Sorry, the session has been expired. I will refresh it if I was not logged in. And so first of all, we can install Azure CLI using the following steps, and I have already updated the system before installing Terraform. We already have installed most of these packages, but still we can install sudo apt update. Okay, now my system is already updated, but for your convenience, I'm rerunning these commands again so that you can see the outputs of these commands. So you can see curl was already installed, gnu pg, and this apt transport https, this package is also used when we install Docker and other DevOps tools. So these actually are utilities. These are small softwares, but these are really helpful because these are dependencies to install the main package. If we are going to install Docker or Terraform or Azure CLI or even AWS CLI, you will see that we have to install these dependencies, and these are really important. So this is just a copy paste command. You must know what are these utilities. These are actually the dependencies required while we are installing any DevOps tools. So we might, in order to avoid errors during the installation, we have to install these dependencies. Now, download and install the Microsoft signing key. Okay, because we are installing the official repository, the official Azure CLI package from Microsoft website. So we have to, for security, we have to sign the Microsoft key, and just I will copy the command and rerun it. So it is saying that mkdir -p, it is an invalid option. So try mkdir. So I will create this directory again, and now I will rerun this command and sudo in parts. Okay, so this command has run. This directory was actually creating errors, so I have removed it and then I have recreated. Now we must have cd key, and we must have the Microsoft GPG key. So that's how, guys, we can fix issues by breaking down the command. So the purpose of recreating these issues is how we can troubleshoot any given error. So that error has been fixed. Now the first step is add the Azure CLI software repository, and we are going to copy this command and just paste here, and we will rerun it. So it is saying that it has been signed by Microsoft.gpg key. So we are now ready to install our Azure CLI. So this command update the repository information, and Azure CLI package can be installed after the update, and then we are going to run the Azure CLI packages. And after that, we are going to install our Azure CLI using this command. Okay, I have mentioned all these commands. So if you are facing any issues with the commands, make sure that you must know via comments, and we can check those commands together. Alright guys, now you can see the following new packages will be installed, and we have Azure CLI installed. This is one newly installed package. Now we can run all the Azure CLI commands using AZ. Okay, now if I run AZ, so it is saying that welcome to Azure, and you can see there are tons of Azure commands. Azure CLI itself is a great tool to manage. Azure CLI is itself a great tool to manage all the Azure infrastructure using Azure CLI. So that's how, guys, you can install Azure CLI using these commands, and I have given all these commands. By the way, if you want to install it using the official repository, you can find install the Azure CLI on Linux, and if you are using CentOS, Azure Linux, OpenSUSE, or any other tool, Azure CLI has all the guides that you can use to install on macOS or on Windows and so on. So I will definitely share how we can install Azure on other platforms if you want to. For instance, if you have Debian on your VM, then this guide can be used that I have mentioned here on my repository. But if you have other OS platforms, then you can use Windows for macOS, and also you can use Azure Cloud Shell, and we can have Azure CLI in a Docker container as well. So these are all guides on official Microsoft Azure website. So back to our Azure CLI. Now we have to create a service principal for our Terraform. This is the mandatory step to set up our Azure environment for Terraform to provision infrastructure. Once it's all set, then we can provision or destroy or create VMs on our Azure platform. So this will actually give permission to manage resources in our Azure account. To whom? To Terraform. So I can copy this command and I will paste it here. Now it is actually Azure AD, Active Directory. We can see this command here as well. You can see Azure Active Directory. And what is the purpose of this? To manage Microsoft Entra ID and also entities needed for Azure role-based access. Azure roles-based access and through Microsoft Graph API. So we are going to use this Azure AD command to give Terraform access to provision virtual machines. Let me repeat it again. We are going to create a principal on our Azure platform, and this principle will give access to Terraform to create VMs. And without having this principle, our Terraform will not be able to create VMs on our Azure cloud platform. Why? Because if I open this our Azure main.tf file or Azure VM.tf file, we are going to discuss it now. You can see we have to define our Azure service principal credentials here. So this command will actually create our credentials, and you can get your subscription ID from your Microsoft Azure account. Okay, you can have like for instance, if I search for subscriptions, now you can see we have this since I'm using the free trial, and you can have your free trial as well. So this is my subscription ID, and I can have this ID from here, and I will use this subscription ID and I will replace it here. Okay, I have replaced the ID, and now I will run the subscription ID as in this command. Sorry, I will clear, and now so it is saying okay, now you can see it is saying that I'm not sure if you can read it. Let me change the colors, and I will not use the system colors for a moment. So you can see I have run this command, and it has created a role assignment under scope. This is my subscription ID. Now I have all these IDs and passwords here created here, and I will use this app ID, display name, password, and tenant ID in my main.tf file, which is here. So you can see it is asking for subscription ID, client secret, and tenant ID. So make sure when you create your subscription principal, service principal, you have to put your subscription ID, and client secret and tenant ID. Otherwise, your Terraform configuration file would not work. Now, I hope that you understand it. So you can get your subscription and you can run this command. I have already shared the command here. You just need to replace your subscription ID, and then you will get all the secrets that are required to be pasted in your main.tf file, and then you can you can provision your infrastructure. So that was actually the setup, guys. For every other service, we have to create a role-based access so that our Terraform knows where I have to provision the infrastructure. I hope you're getting my point. So role-based access are really important when we are going to provision our infrastructure. Okay, and now back to our main.tf file or Azure VM.tf file. This is really important to understand how this Terraform.tf file works. And guys, still, if you have any questions, I would really appreciate if you write those questions in the comment section, and I will try my best to answer every query that you will ask. So you can see this is actually a little bigger file, but don't worry. These are all resources that we are going to create on our Azure portal. And I have mentioned what each code block is doing so that you have a clear picture what are we building here. And now let's understand this file. Guys, this is really important that we must understand. I have this file as well. Let me open it. And this file is used to provision a VM on Google Cloud Platform. And also I have mentioned this file with comments. So you can read all these comments, and we are going to discuss in our next lecture how we can provision infrastructure on Google Cloud Platform as well. So that would be also a quick lab. But now for provisioning Azure VM, we are going to use the Azure Provider, azurerm, and you can search for the providers here and Terraform Providers for Azure, and it is Terraform HashiCorp azurerm, and this is actually the Terraform registry where we have all these providers. Okay, and now azurerm is actually the provider for Azure, and similarly for GCP we have Google, and for AWS we have the provider as AWS. So this is important, and now you can see azurerm is actually the official provider for Azure on Terraform registry. This is actually Terraform registry. We can have every provider information from here, and this is actually the official provider of Azure, and you can see it has over 7 to 7.9 million installs, nearly a billion, and this Azure provider would be used in our Terraform configuration. So now we have this Azure provider, which is azurerm from Terraform official registry, and this feature block is actually an empty block, and it is just to enable the features for this provider. Okay, this provider will have a lot of features, and this block is used to enable all those features. And after that, you can see we have our subscription ID, client ID, secrets, and ID, and we have to paste the IDs that we have created using our subscription ID. So once we have all these IDs pasted here, we are good to go, and we are going to create our resource group, and this resource group in which we are going to create our virtual machine. So I have pasted these comments, and you can see it is actually now it is showing that how we can create a resource. Okay, this is actually a resource, and don't worry about it. This is just predefined syntax of Terraform, and that's how we can create a resource group. We are going to create a virtual network, a public IP address. So we have to mention the resource. Okay, this is actually a resource that is going to be created on Azure. So these are Azure resources, and this is actually the syntax that is used for all the rest of the resources. Resources mean a virtual machine. Resources mean a public IP address, a private DNS, a resource group. So these are all resources. Okay, I hope that now you have a clear picture of resources, and this is actually a predefined syntax how we can have VM underscore RG means resource group, and this is actually the resource group name. We will have this resource name on our Azure portal. We will see, and I have mentioned this location since I belong to Asia, and this is actually the location. If you are using free trial or free subscription, you may not be able to create resources on regions like United States. Okay, so make sure that you choose France or Japan or Asia so that you don't have any conveniences, so that you don't have any problems while creating. That's why I selected East Asia as my resource location. Now my resource group would be created in that location. Okay, and now after that, create a virtual network. That's how we are going to communicate with our virtual machine, and this is actually a virtual network, a private network, and this is the resource you can see, and this block will actually create a virtual network for us. Okay, the other above block that was creating a resource group, using this block, this code block, and now you can create a virtual network using this. And now we can also enter the metadata. This is actually the metadata, and this would be the name of my virtual network, DevOps Molvi VM VNet, and this is the range of the address space. So my VMs in this resource will have private addresses like 10.0.1.2, 1.3, and so on. So, and this is actually the location. Now, from where we are getting this location, we are getting this location from here. Okay, vm.rg. You can see vm.rg, vm.rg. And what would be the location? The location would be East Asia, and this location would be further used in the rest of the source block. And similarly, the resource group name, this resource group would be taken from here, Azure resource group, azurerm resource group .vm underscore rg dot name. Now this is actually the syntax, but you understand how this syntax work. So now you can see this is our Azure resource group, which is azurerm resource group, and vmrg, our vmrg, and the name. So this would be the resource group name, and we will have the output as DevOps Molvi VM RG. So that's how this syntax work. I hope that it is clear. And you can see this resource group and this virtual network will be used further while creating the virtual machine. After that, now this same practice would be repeated again and again. Okay, and so that's why I will say that if you understand this Terraform file, this configuration file, you will not be having any issues further in future while creating other resources on other cloud platforms. So that is actually really important to understand how the Terraform.tf file configuration will work. And now similarly, we are going to create a subnet. Okay, and this is actually the resource azurerm subnet and VM, this the same syntax that we are repeating here. We are going to name the Azure subnet as DevOps Molvi VM subnet, and you can see this is our resource group. Similarly, our virtual private network, virtual net, and similarly our virtual network, and we are getting these values from above blocks. This is our virtual network, and the above code block is our resource group. And after that, this is additional metadata about the prefixes, and our subnet would be created. So these are all requirements for virtual machine. Since we are going to build a virtual machine in a that is actually a full package. We are going to have a resource group, a private subnet, a virtual network, and also a public network, a public IP address, and all these resource block will create that specific resource and provision the infrastructure accordingly on our Azure account. Now you can see we are going to create a public IP address, and this public IP address would be static. We are going to get a static public IP address, and we are going to use this public IP address to connect with our VM. So this is actually the code block for creating a public IP address, and you can see the same syntax is repeating here. This is the location, and the location would be South Asia, and this is the resource group name, which is here the DevOps Molvi VM RG. Don't worry, we are going to see when we run Terraform plan, we will get all these information in our Terraform plan command, and it will show all the output where your infrastructure is being provisioned, what is the resource group name, what is the subnet prefixes, and so on. So after that, once we have this public IP address, we will see what public IP address we are going to get. after we run Terraform plan. And after that, guys, this is really important to have a network interface, and a network interface is used, and this is attached with our virtual machine. And using this network interface, we are actually going to connect with our virtual machine using the public IP address. So we are going to have, we can have dynamic private addresses, but we are going to have the static public IP address. And so that's how we can have just, this is just a virtual network interface card. Our Terraform will have a network interface card, and it will be attached with our virtual machine, sorry. And similarly, the location and the resource group name, make sure that you can name according to your choice. I have been giving DevOps Molvi name for everything, so that I have a picture that what resources I have been building. Now that we have a resource group, we have a virtual network, we have private IP address, we have public IP address, we are going to configure our IP address configuration, and we will use this code block to configure the IP address to our virtual machine. And we will have just like we have a physical IP address attached to a server, we will have a public and private IP address attached to our virtual machine. And after that, we have completed all the prerequisites for our virtual machine. It's time to build or provision our virtual machine using Terraform, and we will be using all the prerequisites that we have created, like resource group, virtual network, subnet, private IP address, public IP address, and we are going to use all of that here in our virtual machine source code block. You can see I'm creating a VM. This would be the name of the VM, that is just like host name, and this is location South Asia, and the resource group name as DevOps Molvi _RG, and this is actually the network interface ID. So it will get it from here. Okay, this is actually the network interface azurerm network interface .vm _nic, and we will have this name as our network interface card. So similarly, we have this size. This is the VM size that we are going to create on our Azure, and this is actually the username, and I will use the SSH key pair, and this would be the username to log in to our VM. And after that, guys, make sure you create a public key. I have already created here on my VM cd SSH. So I will use this SSH key pair to connect with, this is the actually public key that I'm using. I have the key pair with me, and I have given the path from where our VM will have the public IP address, the public key, sorry. And ensure that you have an SSH key pair created. I have already created. Make sure you create one for your VM. And after that, OS disk, and this is just like when we create a VM, we give the information about disks. This is actually the caching as read write, and so this is actually the storage account type. And after that, source image reference, and from where I am going to get the operating system. So this is actually the Ubuntu, and this is the release that I'm going to install. It is 18.04 and version is latest. And output the public IP of the VM. We are going to get what public IP address we are going to get. So I have all this configuration. This is actually the Terraform configuration file, and I have it here on my VM. So on CD Azure VM. Don't worry, guys, we will have more lectures on Terraform, and so we will make our concepts more stronger as we discuss more other Terraform configuration files. So I have this configuration file here and main.tf. So you can see I have replaced my Azure principal credentials here. These are my Azure principal credentials that I got using this command. Okay, I run this command. I have already shared this command on the GitHub repository, and after that, everything that I have used here updated accordingly, and I have the SSH keys. So we are ready to initialize our configuration file, and that's why I will run Terraform init command. This will initialize an empty Terraform directory. What is the purpose of Terraform init? And we get the information from here as well. It initializes the backend, Terraform backend, where our terraform.tf state is saved, and it also has initialized the plugins, and plugins are we get those plugins from our provider, which is azurerm, which is our provider. And you can see this is the provider, and we have used previously installed Azure AM and using previously installed this provider version. Okay, Terraform has been successfully initialized. Now you can begin working with Terraform. Okay, and try running Terraform plan. Okay, and we are going to run this command, so it will give us a overview or a general picture of what we are going to build. So I'm running Terraform plan, and now we will get the full information of our infrastructure. Okay, now you can see what we are going to get here. Okay, so I'm sorry it becomes a little overwhelming for DevOps beginners, but if you understand it, if you focus it, everything is pretty straightforward. We are having everything here that we had given in our .tf file. So this is actually a JSON format, and we are having an overview of our infrastructure, what we are going to get. You can see I have given this name, and this is the same name I have given in my .tf file. So we are going to have this information what Terraform is going to provision. Now furthermore, this is my SSH public key, and it has taken my public key from the VM. And after that, this is my release, operating system release. And similarly, you can see the location, which is East Asia, and our address prefixes. There are some things that it is saying that known after apply. What does this mean, known after apply? And similarly, public IP address. So we are going to now run Terraform apply, and that's why some of the things, some of the credentials, we don't have the public IP address. So it says that when you will run Terraform apply, you will be given this information as well. So that is actually the meaning of known after apply. And we will get the information about, for instance, what is our DNS server? We don't know. What is our public IP address, or what is the ID? We don't know yet. And when we run Terraform apply, it will not only provision the infrastructure, but it will also share the information about our public IP address, our DNS server, and our GU ID and ID. So this is the actual meaning of known after apply. Now it's time to apply, and what Terraform apply will do, it will actually create all the resources, resource group, virtual network, private IP address, private subnet, the virtual machine, the disk, the network interface card, and everything that we have in our .tf file after running Terraform apply. So I will run Terraform apply, and we will have our infrastructure or our VM created, and it is saying that we are going to add 6 resources, 0 to change and 0 to destroy. So everything would be created for the first time. So what is the plan? 6 resources, all the resources we have here, virtual machine and resource group, network interface, public IP address. All these 6 resources would be going to create, and there is nothing to change and there is nothing to destroy. So I will it is saying that only yes will be accepted to approve. So we have to write yes so that it starts creating our resources. Now we have to sit back and see our resources are being created on our Azure platform or Azure cloud. So you can see resource group has been created, and similarly the subscription, using this subscription, and public IP address is going to be created, VNet virtual network is going to be created, and every infrastructure resource we have given in the .tf file is getting created. So we have to wait for a while. Now you can see our virtual machine is going to be created. This is the last step, and we will have our virtual machine on our Azure cloud, Azure portal. So we will definitely check where our Azure VM is created. If I refresh my resource group, okay, resource group, so we must have a DevOps Molvi VMRG has been created just a while ago. Okay, so the resource group has been created, and you can see all other resources have been created here. We have DevOps Molvi VM NIC. Now we have our DevOps Molvi Linux VM as well. So it has been created. Okay, finally our apply has been complete, resources have been added, and our VM has been created. So that was actually the output. We have this public IP address, and the same public IP address we should have on our Azure. So I will copy it, and let's see if we have this IP address. Okay guys, you can see this is our IP address, and every information we have here, you can see the private IP address is 10.0.2.4, okay, as per our prefix, as per our subnet. And similarly we have this standard DS1 v2. Now let's compare the values we have given here in our address prefix. And now I will check the address prefix, and it should be like .0. okay, now this is the address now this is actually the address prefix, and it is good. And also we have the static IP address, and also we have this standard DS1 v2. okay, we have this standard DS1 v2. So everything we have. Now the source image plan is also 18.04 LTS, which is the same we have here, 18.04 LTS. okay, and we have everything created. We have all these resources created on our Azure platform. So if I check resource group, this is my resource group, and I have all other resources created within the same resource group. And guys, you can see we have this VM, we have NIC public IP address and VNet. This is also the information about disk, and we can expand every resource to check what was created for us. So that's how, guys, we can automate our infrastructure provisioning. This was actually the first step to terraforming. This was our first step to create resources and a virtual machine, and we can have all this information here. And this is our public IP address. We have the same public IP address that we you can see we got from we have this information, and we have matched the public IP address as well. And now we have everything associated with this network interface card, and then this is actually associated with our virtual machine. So those resource group that we created were all prerequisites for our virtual machine. We created a resource group, a virtual network, a subnet, a network interface card, and after that we configured the IP configuration and attached everything to our virtual machine. And once we have all that set, we created our virtual machine. So you saw that how we created resources using Terraform. If I want to destroy all these resources, finally I will use the Terraform destroy command, and my resources will be deleted or destroyed. So it will also show us that these resources will be destroyed. Are you sure? And it will also ask our approval before destroying the resources. Now I will say yes, and our resources will be destroyed. So now our VM, resource group, subnet, network interface card, public IP address, private IP address, everything would be deleted. So by the way, this is a dangerous command, but we have to use it for destroying our infrastructure and rebuilding after making some changes. So now you can see our infrastructure is being destroyed, our virtual machine is going to be destroyed, and resource group and everything inside that resource group would be destroyed. So we have to wait a little bit more. Now some of the resources destruction has been completed, and some resources are still being destroyed. So since there are 6 resources, so that's why this is actually taking a little longer. And once a resource is destroyed, we get the information, the log, that this resource has been destroyed, its destruction has been completed. All right guys, now you can see the destroy has been completed, and resources, there were 6 resources that were destroyed. If I refresh this same page, and I should get an error that this VM no longer exists on my Azure platform. So that is why okay, so you can see this, the virtual machine resource was not found. So that's it guys, this was our first practical lab of Terraform, in which we created a couple of resources using one main.tf file. Now we are going to work more, and we will organize our Terraform configuration files, in which we will have a separate file for providers, separate file for variables, and that's how we are going to work with Terraform modules as well. So make sure that you use this configuration.tf file to provision a VM on your Azure portal. You can have a free subscription of Azure if you're a student, and or if you don't have Azure portal, so you can have a free subscription and enjoy 30 days free resources on Azure, and you can build your infrastructure on Azure. So if you have any questions, feel free to ask me in the comments. I would love to answer every query that you have. And also guys, this is actually the DevOps Molvi for Terraform, and this would be our official repository in which we will share every knowledge that we practically work in our video lectures. And make sure that you clone this repository. Make sure to give it a star, to give this repository a star, and you can keep watching it. We are going to make changes on this repository. Finally, I would really appreciate your appreciation. Finally, I would really appreciate your subscription on my YouTube channel. Make sure to give me support, and I'm really thankful from the bottom of my heart. I will see you in the next video. Till then, have a good one. Bye. Hey guys, I hope you're doing great today. This is our second lab on Terraform, in which we are going to provision some more infrastructure on Google Cloud Platform. Guys, in the first lab, we were playing on Azure. We provisioned around 6 resources, including resource group, private subnet, public IP address, virtual network, and a VM, virtual machine, on Azure. So today we are going to have a little bit fun with Google Cloud Platform. Guys, having experience on multiple cloud platforms like Azure, GCP, and AWS, it makes you a great DevOps engineer, and it increases the chances of your job whenever you apply, if you are multi-talented with multiple cloud platforms. Okay, so but it is not mandatory, as I told you in the very first lectures of my DevOps roadmap, that at least you must know one cloud platform, whether it is AWS, Azure, or GCP. But if you want to excel more in DevOps, then if you can manage to learn the 3 major platforms, including AWS, Azure, and GCP, it would be great. It would be fantastic for your career. So it is not mandatory, as I said in the beginning, but knowing at least one platform is a must. And it is really hard to survive in the DevOps market if you don't have experience on any of the cloud platforms. So this is also my goal, and I'm ambitious that I should teach you the cloud platforms as well, while we are working on other DevOps tools like CI/CD and Docker, and now we are working on Terraform. So you can see that we are also learning about cloud platforms a bit, right? Not a deep dive into the cloud platforms, but we are having some general ideas how any cloud platform looks like and how we can provision infrastructure on Azure or GCP. So today, this is actually our lab number 2, and this is also a similar lab as we had yesterday on Azure. And today we are going to have lab 2 on Google Cloud Platform. And you don't have to worry about it, because everything would be managed on this Terraform by DevOps Molvi repository. So we have this lab 2. So should we get started? Okay, let's get started. And this is actually lab 2, and we are going to provision some infrastructure like a VM, storage bucket, etc. on our Google Cloud Platform account. But before that, we must understand what we have here and how things are being worked using this lab, how we can provision some virtual machine and a storage bucket on Google Cloud Platform. So there are a couple of files that you can see. And guys, by the way, this is a public repository. Okay, I have made it public, and you just have to clone it on your VM. Okay, I will tell you what do you have to change to make it work, right? So this is actually Terraform by DevOps Molvi, and you just need to run git clone and this repository. Okay, so you just need to copy the URL from here, and you just need to run git clone and the URL of this repository, and you will have everything. We had Azure VM, and also today we are going to have lab 2 on GCP. So if you want to work on installing Azure CLI and provisioning Azure VM with other resources, you can have a look here as well. And then everything is all set up. You just need to clone, and you have to do some little bit tweaks so that it can work for you. All right, so this is actually our lab number 2, and we have these files: credentials.json, creds.json, key.pub, main.tf, pizza.png, and story.tf, terraform.tf vars, and variables.tf. So everything is all set up. I have personally tested it, and then I pushed everything to this GitHub repository so that you can easily clone it and you can start understanding and how it works. But in today's lecture, we are going to discuss it in detail. This is actually the main.tf file. Guys, in the last lecture, we were having everything included in main.tf file. We didn't have any other Terraform configuration files like variable.tf or tfvars or outputs.tf. So we are going to more expand the Terraform configuration, and we will organize it properly so that we have a clear picture how things are working. And it is better, a great practice, to organize your infrastructure so that anyone can see and understand it, how the infrastructure is provisioned and how it is working. So we have this main.tf file, and now you can see that there are actually variables here. Now this is var.myproject, var.region, and that's how we are creating a virtual private cloud. So everything is not mentioned or given in main.tf file. So from where these variables are being taken, and Terraform is taking those variables and using them while provisioning the infrastructure, we have actually this variables.tf file. Okay, let me open it here. This is actually the variables.tf file. So it is actually the best practice to create separate files for all the variables we are using in the infrastructure provisioning. Oh, sorry. Why it is giving error? Okay, I will refresh it. Okay, everything is good. So now you can see there are around 13 variables being used in this Terraform configuration. In this lab, we are going to use all these variables. Now we have declared these variables in this variable.tf file. Okay, but where are the values of those variables? For instance, if I have this region, variable region, then I'm using this region variable here as var.region. Similarly, I have this my project, and I'm using this var.myproject, and it will take the values. But from where? Where are the values that Terraform will take? So we have this terraform.tf vars, and I have given all these variables in terraform.tf vars. So we have the region, we have the project, credentials, names, every variable, it has the values in terraform.tf vars. Now you can see In order to change the whole file, we just need to change the variables.tf and tf vars. That is actually the beauty of declaring variables. And now I'm using these variables var.myProject everywhere in my whole main.tf file. So for instance, if I want to have to change something, and in order to modify all this configuration file main.tf, which may break the configuration, so it is better to change only the variable here and the value here in terraform.tf vars, and then those changes would automatically be replicated in your main.tf file. So I hope that now you understand what is the purpose of variables. Variables actually help us to organize, and also it is a good practice, recommended practice, to declare the variables, and those variables should be used in our network.tf, firewall.tf, storage.tf, main.tf, or provider.tf, other configuration files, outputs.tf. And these variables make it really easy, and we don't have to break, or we don't have to modify our main configuration files like main.tf. So that is actually a different and the recommended approach. Now for instance, let me again open it, and so now we can compare the main.tf file of Azure, the VM that we provisioned yesterday in lab 1. Now you can see I am using only one file. This is Azure VM.tf file. You can say it is the main.tf file. Now I am giving all the values directly in this main.tf file or Azure VM.tf file, and I am using only this one file to provision the resources and a virtual machine using Terraform on Azure. Now you can see everything is being given in this same one configuration file, and that's why it becomes a little complex, because you can see all the values have been given in this same file. Now the difference between, actually what I want to show you, how we can better understand and quickly understand using variables.tf and terraform.tf vars. Now I have a clear picture that this is the region, this is my project, these credentials are the .json file, which we will definitely create after we create a service account, and this is the name of the environment, sandbox, and this is subnet. We are going to have private IP addresses, and the name of the server, machine type, zone, and the user for SSH access, the public key for SSH access, and bucket name for storage bucket. Storage class would be standard, and bucket location would be the same as our VM. Now all these variables are declared in variables.tf, and every variable is picking up the value from terraform.tf vars. For instance, if I am going to add load balancers in my this project, this configuration, so instead of changing the whole main.tf file, I would simply add variables in variables.tf file here. And guys, by the way, I was having this variables.tf file only for creating VM. This value, the values that I added after modifying variables.tf, these variables were added for storage bucket. So that's how we can add more variables, and that's how we can declare the variables values in terraform.tf vars. And this actually looks more professional, and it is also the recommended approach. So whenever now you are going to work further with Terraform, you will see that Most of the companies, most of the infrastructure provisioners are using variables.tf, terraform.tf vars, outputs.tf, provider.tf, separate file for each of our resource, each of our configuration. And now you can see this one file that we used on Azure. However, if we understand it, then we can quickly get our hands on it. But for a beginner, it will obviously look a bit difficult and challenging. That's why now we have organized it into variables.tf and terraform.tf vars, and I am using this main.tf file to get the variables from variables.tf file. So we have to declare this variable. Now you can see var.creds. This is actually the variable for credential files. So we must have a credential file here. So we will have it. So that's how we are going to communicate. We are going to talk with our Google Cloud Platform account, where we are going to provision our infrastructure. Just like we created a principal on Azure, here we are going to create a service account, and we are going to use the keys which are in the JSON format. You can see here I have those keys here. Now this is actually the service account, and I'm using this service account .json file so that our Terraform can communicate, can talk with our GCP account to provision the infrastructure. Now this credential file should have the access to provision the infrastructure that we want. Now for instance, I'm going to provision a virtual machine and a storage bucket with images uploaded on this storage bucket. Then definitely my service account should have the access to Google Compute and Google Storage resources. So that's how we will use the credentials here using the credentials.json file. So you can see we have this variables here as well. Now this is the variable, and here this is actually my service account file.json. So you can I will use DevOps.json. You can rename it, but make sure that you update this file accordingly. And if you don't update the file, you don't update the values here as per your account, maybe Terraform configuration will not work and you might encounter errors. So make sure that what name. Now for instance, I have this my service account file.json. So now if I go to Terraform by DevOps Molvi, and if I list cd lab 2 and clear ls minus l, and now you can see I have changed this DevOps Molvi.json file, and you must change this file when you take the poll. Or if you want to have the same name, make sure that this is just for understanding. Make sure you paste your credentials in the correct file. So I'm using my service account file so that you can change it accordingly. But for my own testing, I'm using this DevOps Molvi.json, and you can see I have the credentials here. Sorry, DevOps Molvi.json. So I have this service account created on this lab project and everything. Now this is actually the service account Terraform Lab 2, and it is created on Google Service account, and this is actually the client ID. And I'm using this service account so that our Terraform can talk to our Google Cloud Platform and we can provision the infrastructure. If you don't want to change this value, then that is okay. but I would recommend that you must change the file names so that you must learn how things are working, from where we are getting those variables, from where we are getting the values of those variables. Now after that, the same practice would be carried out, and you can see we will have the variable for our virtual private network, and we have the variables for subnet. Similarly, you can see we have var.name, and this is how things are working using variables and terraform.tf vars. And similarly, we have the firewall configuration. So it is actually a new addition as compared to our previous lab, and that's how we can configure and allow SSH ports using Terraform. This is actually the firewall configuration, and now you can see this is actually the resource Google Compute Firewall, and the name var.name, which is the variable here. Now what should be the name? We have this name here, variable name, and what is the name? Sandbox. So we will have this as sandbox hyphen firewall. We will have sandbox hyphen subnet. So that's how our variable will change the values. Don't worry, when we run Terraform plan, we will see how the values have been updated from variables.tf and using terraform.tf vars. Now there are a couple of rules. We are allowing ICMP for ping, SSH port, and HTTP and HTTPS ports, and we are allowing them for all the source ranges from everywhere. Okay, so this is actually the range which tells us that only these ports are allowed on that VM from everywhere, and we can restrict as well using our own IP addresses. So if I want to restrict, then I should change the source ranges. Okay, so that's how we can have firewalls rules created using Terraform. And guys, this is actually the resource that is going to create a virtual machine on Google Cloud Platform using var.server as the name and machine type. Everything would be taken from here. Now this is actually var.server. So the name of the virtual machine would be my VM, and similarly the machine type would be F1 micro, and after that the zone would be here US Central 1A. So we will definitely compare after provisioning the virtual machine that whether our Terraform has taken the correct values and it has provisioned the VM correctly according to our variables, according to our choice. So this is the tags web and dev to that virtual machine, and this is for the image that would be installed on our virtual machine and the name of the disk. After that, guys, now you can see the metadata for our SSH keys, and we are going to use the GCP SSH user, which should be DevOps Molvi. I have this here in variables.gcp SSH user, and it should be my user, and you have to change the names. Okay, I'm repeating it. You have make sure that you change the names so that you learn from where every change is working. So I will have this as DevOps Molvi, and I had the DevOps key.pub as my public key. You can see this is change here, and I have in main.tf, let me show you in variables.tf, nano variables.tf. So you can see I have these variables here, and now I have changed the name and values of these Terraform variables here, you can see my user is DevOps Molvi, and the key is DevOps Molvi.pub, and the credentials file is DevOps Molvi.json. So I have named everything according to that file. If something is missing, then Terraform will throw errors that this file or this directory is missing or I can't locate it. So make sure that you must update the files accordingly. Okay, and that's why these values are actually just dummy values, and I would recommend that you change them with your names. And when you are going to change the values according to your name, you will have a better understanding how the infrastructure is working. Okay, and after that, finally we will have the network interface card, and this network interface card is used to connect with the VM using public IP address. So guys, everything is set up. Now this was actually for the virtual machine. Okay, now we will have another file for storage.tf for Google Cloud Storage, and the same approach that we have used while creating the virtual machine, we are going to use the same thing here in storage.tf as well. And you can see this is the variable var.bucket name. And now what should be the bucket name? This is actually the variable declared in variables.tf, and this should be the name as pizza images. Okay, and after that, storage class would be standard, and the bucket location would be the same as US Central 1, and this is actually the zone where our region, where our bucket would be created. And force destroy is true, and uniform bucket level access is true. When we are going to run Terraform destroy, the bucket and its content would be destroyed. And we have enabled versioning, and after that, this is the more specifications or more features of that bucket, its life cycle, and we will have only 3 versions, and that is actually the life cycle rule, or this is actually the metadata of that bucket, the versions of that bucket that we will maintain, and what should be there inside the bucket. And this is actually the bucket name, pizza images. I can use the var.bucket name here as well again, but I have hard coded the value. This is actually pizza.png, so I have this pizza.png file here as well. So that is why, guys, everything is configured accordingly, and you just have to clone it and run it. It is delicious and it looks yummy. But let's focus on our storage.tf file, and you can see the same thing that we used in creation of virtual machine. We can use those variables to create a storage bucket, and our storage bucket will have one image to be uploaded using Terraform. So this Terraform storage file will create a bucket named as pizza images, and it will have this my image. And what would be the my image? It is pizza.png. So everything is set up. We have cloned this. You can take a clone of this repository, and we have this lab 2, and every file, every credential, and everything is set up so that we can just run Terraform commands and our infrastructure is built. So for instance, now I run Terraform init file, Terraform init which will initialize. Now you can see Terraform has been initialized, and now you may begin working with Terraform. So we are all set, and you can ignore that because it is deprecated, means it is no longer active and in active use. So we can change or remove it. But now I run Terraform plan, okay, so that we must have an idea of what we are going to build. And running Terraform plan, it is throwing some errors, and it is saying that unexpected end of JSON input, and we don't have the JSON credentials are not valid. So we are getting this error because let's check what we have in JSON. Do we have the credentials? Nano DevOps Molvi.json, and the file is empty. That is why we are getting these errors. So I have to create a service account, and now I will use this IAM, identity and access management, and we can use a service account to create a service account so that we can provision infrastructure. And now service account, on identity and access management, create a service account, click on that. I will close it. Now this would be the service account name, Terraform Lab, Terraform Lab 2. I have already this name, and create and continue. Now we will have to give access to this service account so that we can use it in our Terraform credentials.json file. So I will have a compute admin role, so that it has compute admin, full control of creating compute resources, and I will add another role as cloud storage. So that's how we can add roles as well. This should be cloud storage, and I have to find it here. Cloud storage and cloud storage and cloud storage admin, cloud SQL, cloud storage admin. So I have these two roles created only for this service account, and this is for the sake of this lab. It is not a recommended practice to give the full access, but for now I'm just creating because for this lab, and I will continue. This service account will have full access, full power of creating compute resources and storage buckets, and I will click on done. And after that, you can see we have this service account created, okay, in Terraform Lab 2, and there the account has been created. Now I will click on it, and I have to use the JSON keys, and from where I can get those JSON keys, I will use the keys part here, and I can create a new key in the JSON format and create, and it will download. You can see it has downloaded the key here, and I have this key on my computer. I will edit it, and I will copy the content of this key, and then I can paste here in DevOps Molvi.json, shift insert. I have pasted, and I have saved the file. Now I hope that we are not getting any errors while running Terraform plan. So guys, it's time to run Terraform plan. I will run it, Terraform plan, and now we will have a clear picture what kind of resources are we going to have. So now if I have a quick overview of Terraform plan, then you can see every information that we have in our Terraform configuration files are printed here. And now we can go through the Terraform plan. What did it print? So you can see we have the network here. It is sandbox VPC, and also we have these firewall rules that would be allowed. Also we can have the information about our VM instance, and you can see the machine type and also the SSH keys here. And after that we can go through the name of the VM, which is DevOps Molvi VM. So we must have this VM created with the following tags: dev and web. And also we can see the zone, which is US Central 1. And all all the information is printed here. So Terraform plan is a great command, Terraform command, which gives you an overview of your infrastructure before provisioning it. And once we are good to go, we can then run Terraform apply, and it will actually start provisioning the infrastructure. So to me, everything looks good, and that's why I would proceed towards Terraform apply, and I will run it. So let's see how it goes. And now it is saying that enter a value. We can auto approve it as well, Terraform apply hyphen auto approve, but I will run in this way. And now you can see that, guys, my infrastructure has been started being provisioned on our Google Cloud platform. So it will take a couple of moments, and now you can see our VM, network, bucket, instance, firewall, subnet, everything is being created, and it takes a couple of moments, and once done, it will show us that everything has been provisioned. So now VM instance is still being created because it is a virtual machine, so it takes some time. We are getting this error because it says that the specified bucket does not exist. So I will rerun the command to see why are we getting this error, because the configuration looks good and we can see the Google storage bucket object picture will be created. It is saying that if it has to show any errors, it must show when we run Terraform apply that this bucket cannot be created. So I will see, and I will rerun yes to see if we encounter this error again. And now, guys, you can see the command ran successfully. So the purpose of showing you this step is that if you encounter any error, make sure that you can try running Terraform apply again. So sometimes it happens quite a lot with me that Terraform apply shows some error. So one of the best practice is to retry it, and when you retry, you can see it has fixed. So we have provisioned the infrastructure on our Google Cloud platform. So I will check compute instances here on compute engine, VM instances, and we must have a DevOps Molvi VM. Okay, and we can also connect using the SSH, and it will ask for the SSH keys have been transferred, and you can see we are now able to access our VM. Okay, guys, and similarly we can also see our cloud storage, and in buckets we must have a bucket named pizza images created with one pizza image uploaded. So pizza images, you can see the bucket has been created, and it should have pizza.png. Okay, if you remember, we have this image here in pizza.png, and we should have it uploaded. You can see my new image, this was the name of the image, and if I open it in a separate tab, you will see that our pizza image has been uploaded as well. So guys, that was actually the drill to create infrastructure, to create VM storage bucket on Google Cloud platform. If I quickly repeat it, then you can see we have everything created on our Terraform DevOps Molvi, and we have Lab 2 where we have all the files, necessary files, credentials, public key, Terraform configuration, main file, pizza.png, an image that we are going to upload to our storage bucket, and storage.tf, and variables that have been declared according to our environment. So everything was updated accordingly here when I cloned it on my Linux VM. So you can see we have DevOps Molvi.json, which contains our keys or service account credentials so that we can provision infrastructure on Google Cloud Platform. After that, we have this SSH key, and we have this main.terraform configuration file, and we have these variables.tf and terraform.tf vars, which contain all the variables. So guys, that's how we can provision infrastructure on Google Cloud Platform. Once we are good, we can destroy it, and I will run terraform destroy. So it will remove everything and everything would be destroyed. Don't worry, we are going to have a full lecture on Terraform state file, which you can see the states are refreshed, and we will have a full lecture on Terraform states. You can see refreshing state, and we are going to have a lecture on Terraform state file and locking. I will enter yes, and my infrastructure would be destroyed, and I will give it a try once more to see if our configuration files are working perfectly. Alright guys, destroy completed, and our infrastructure must have been destroyed. If I refresh and see the buckets, you can see there are no buckets. And if I want to run Terraform apply again, and it will now the refresh, the state would be refreshed, and we will have our infrastructure created again. And now you can see I'm recreating the infrastructure. I'm recreating network, VPC, and storage bucket, and also we are going to have our VM recreated. So if I check my VM, it should have been deleted as well. So compute engine, and there shouldn't be any VM here since we have destroyed. Okay, you cannot find any VM. Make sure that you take a clone of this repository and run it on your VM. And if you face any errors or issues, feel free to let me know in the comments. We can solve, we can work together. We are all DevOps learners, we are all DevOps enthusiasts. So we have to make everything work together, and we will have this pizza when we win. So I'm pretty sure that you will do it on your virtual machines, and you are going to have VM and bucket created on Google Cloud Platform. In case of any issues, feel free to let me know in the comments, and make sure that you subscribe my channel DevOps Molvi on YouTube. I will watch you in the next lecture. Happy terraforming and have a great weekend. Bye. Hey guys, I hope you're doing great today. Well, today this is one of the most important Terraform concepts we are going to discuss in today's lecture, and it is Terraform state file. So that would be our DevOps chapter number 32 of our DevOps roadmap 2024. And guys, we are just near to 900 subscribers, and I would really appreciate if you subscribe DevOps Molvi on YouTube. Let's start our one of the important concepts of Terraform today, which is Terraform state file. So let's get started. Alright guys, so let's have a quick review. Okay, we have covered so far what is Terraform, and also we had 2 labs in which we provisioned some little bit infrastructure like VM and storage bucket on Azure as well as on Google Cloud Platform. And also I have shared the repository link where all the files and Terraform configuration files are being uploaded, and we are together maintaining that repository, and where I have also shared with you guys how we can install Terraform, how we can install Azure CLI, and we also configured Azure CLI and logged in to our Azure account. We created principal for Azure, and also we created a service account for Google Cloud Platform. So if you have an account on both these cloud platforms, Azure and GCP, I would recommend that you must try these labs. I have already shared their links in their description. So what is Terraform? It's a quick review so that we can keep our concepts fresh every time. And now I'm pretty sure that you must know what is Terraform, and it is a tool for building, changing, and versioning infrastructure safely and efficiently. And also, Terraform can manage our existing popular service providers and custom in-house solutions. And the set of files used to describe infrastructure in Terraform is known as Terraform configuration files. You know, main.tf, provider.tf, storage.tf, network.tf, outputs.tf. And also, Terraform enables you to safely and predictably create, change, and improve our infrastructure, whether it is on cloud or it is on our on-prem data centers. Terraform is one of the best infrastructure as code provisioning tool, and it is used to provision our infrastructure. So you also know that we have been working with these major commands so far: Terraform Init, Terraform Plan, and Terraform Apply. So each command has a purpose, and I have shared what each command does so that you can refresh your concepts. And Terraform Init will actually initialize various local settings and data that will be used by subsequent commands. So we have been working on these three commands: Terraform Init, Plan, and Apply. Okay, so we also know the difference of these three commands. Terraform Init, it actually initializes various local settings and data that will be used by the subsequent commands. So before running Terraform Plan and before running Terraform Apply, we have to initialize, and this Terraform Init command will also create a .terraform folder, and also after that we are ready to run Terraform Plan. And this command is convenient way to check whether the execution plan for a set of changes matches our expectations, and Terraform Plan, in which we get an overview of our execution plan, whether it is correct and as per our expectations, so that we can provision. So Terraform Plan also prints the output in JSON format, in which we get the information about our infrastructure. And after reviewing Terraform Plan, we are ready to run Terraform Apply, and it will create and change the real infrastructure to match the configuration. What we have written in our configuration files, which are Terraform files, main.tf or provider.tf. So Terraform Apply will actually provision the infrastructure as per our configuration file. So we have been executing and running these commands a lot: Terraform Init, Terraform Plan, and Terraform Apply. And if we want to destroy or delete our infrastructure, we have run Terraform Destroy, which will delete our infrastructure like virtual net or resource group or VM or storage bucket or the data inside that storage bucket. Everything is deleted when we run Terraform Destroy. So these are actually the most common Terraform commands, and I wanted to revise it with you guys. Now, what is Terraform state file? That is actually the today's topic of our discussion, and we will practically see the changes happening in Terraform state file. So what is actually Terraform state file? When we run Terraform apply command to create an infrastructure on cloud, Terraform creates a state file called terraform.tf state. Okay, this file terraform.tf state is created after we run Terraform apply, and this state file contains full details of resources in our Terraform code. Whatever we have in main.tf or story.tf or network.tf or provider.tf, every information that is printed while we run Terraform plan. And you saw that when we run Terraform apply, it says that I'm creating a resource group, I'm creating a VM instance, I'm creating a storage bucket. So everything is being provisioned and the state of that infrastructure is being maintained in the terraform.tf state file. Guys, when I started working initially with Terraform, and that was the exact same question appearing in my mind, that how Terraform maintains the state of the infrastructure. For instance, if I have created 2 VMs or 3 VMs and storage buckets and load balancer, what if I make some changes in the code and rerun it, whether it will recreate every VM again or load balancer or storage buckets again? No. That is the purpose of Terraform state file, and it contains every information of our infrastructure that has been provisioned already. So when we have this state file, Terraform knows that I have already 2 VMs, and if one more VM is being added, it will not create 3 VMs all again. It will create only one more VM, that is an additional you can say instance being added to our infrastructure. So the purpose of Terraform state is to maintain the information of our infrastructure. Nothing is going to be recreated again and again if we run Terraform apply for thousands of times. I hope that I'm able to clear the concept of Terraform state file. Terraform state file has the information about our IP addresses, about our subnets, about our VMs, about our storage buckets, and when we add something in our Terraform configuration file and reprovision the infrastructure, that file is updated accordingly, and more additions to our Terraform plans occur when we grow our infrastructure. So the purpose of Terraform state file is that when we modify something on our code, okay, we have modified Terraform configuration files and we are going to add something in those configuration files, and we run Terraform apply. Okay, from that point I hope you are clear. Now Terraform will look into the state file. What is there in the state file? What infrastructure we already have in the state file? Terraform will not reprovision that infrastructure. Okay, and then it compares the changes made in the code from that state file and the changes to the infrastructure based on the state file. Anything new is added into the Terraform configuration file will be provisioned only when we run Terraform apply. So if there are no additions and we run Terraform apply, it will see the Terraform state file and it will say that there are nothing new changes in the code, everything is good, and it will not reprovision anything new. So guys, I hope that now you are clear. When we run Terraform apply, it will create a terraform.tf state file, and that state file contains every information about our infrastructure. When we modify something into our configuration files, Terraform will look into our state file and it will add or update our infrastructure after taking a look into the state file, and then it will provision if anything are being added into our infrastructure. And it is impossible to maintain our infrastructure if we don't have a Terraform state file, or if we do not take care of our Terraform state file. It would be really hard, or I would say that it is impossible to maintain large infrastructure if we don't have a Terraform state file. Additionally, there is more knowledge for you guys about Terraform state file. That Terraform state file is written in a simple readable language, which is JSON. And also, when Terraform creates a remote object in response to a change of configuration, it will record the identity of that remote object against a particular resource instance, and then potentially update or delete that object in response to future configuration changes. So every object, like we create a virtual machine, will have an identity that would be stored in the state file, and that is actually being recorded in the state file. So if there is anything happening against that particular identity, Terraform will potentially update or delete that object as per our commands. For instance, if I am running Terraform destroy, then definitely Terraform will have a look into the Terraform state file. So the primary purpose of Terraform state is to store bindings between objects in a remote system. From remote system, it can be Azure cloud, it can be Google cloud, and resource instances declared in our configuration. So Terraform takes a look on the cloud platforms where our infrastructure is being provisioned. It also at the same time looks into the configuration file, and also at the same time it takes a look on our state file. So that is why I would say that Terraform is one of the best infrastructure as provisioning tool, because it manages the whole infrastructure, and it has the idea of objects created on our cloud platforms. It has the idea what we have in our state file and what I have to provision anything new if our code is changed. So without Terraform, as I said, it is really impossible for Terraform to manage the infrastructure, and that is why it is one of the key responsibilities of DevOps engineers to maintain that Terraform state file. Okay guys, now Terraform backup state file. But before that, let me log in to our Azure VM. This is actually Azure VM, and I have to change the settings, colors, use system colors, and appearance. Sorry for taking a couple of minutes, I would say seconds. Now you can see that we have both files, terraform.tf state and terraform.tf state.backup in this folder, and we have this folder. This folder is actually created when we run Terraform Init. And let's see what we have in that folder. And it contains providers, the information about our provider, and there is azurerm that we are using it as a provider, cd providers. And now you can see we have this provider on our registry. I have already shown you in our first lecture that all the providers we have here on our Terraform registry.terraform.io. So we have providers on about Azure, about GCP, AWS. Every provider would be here in the Terraform registry. So when I run Terraform Init, it says that initializing the backend. Okay, and now we are having our backend on our this VM. So there are actually two types of backends that we are going to discuss in our upcoming slide: local backend and remote backend. So for now, you need to understand that where our terraform.tf state file is stored or present, it is actually the backend. Now I have this terraform.tf state file locally on my VM. So it means that my backend is local backend. If I have this file stored on Azure storage or Amazon S3 bucket, then that would be my remote backend. Okay, so for now it has initialized the backend, which is our local backend, and it has initialized provider plugins from the information that is stored in this hidden folder. And after that, you can see reusing previous version of HashiCorp azurerm. Then now this is actually the provider from the dependency log file, and this is actually the log file. And now we can see what we have in this log file. This file is maintained automatically by Terraform Init, and manual edits may be lost in the future updates. So this actually contains the information about our Terraform provider. So this is actually the purpose of Terraform Init command, to initialize the backend, to initialize the provider plugins. And we have those provider plugins in our .terraform, which is actually hidden. Just like we saw, we had .git folder, and it contains every information about our repository. So we can say that we can relate that .terraform contains most of the information about our Terraform. And after Terraform has been successfully initialized, we have to run Terraform plan. But since I have already run, and that's why I have these two files, terraform.tf state file and terraform.tf state.backup file. Now back to the presentation. I just wanted to show you that we have these two files after we run terraform apply command. When we run terraform init, our backend and provider plugins are initialized. When we run terraform plan, it shows us the execution plan. Terraform actually shows us the execution plan, how our plan or how our infrastructure is going to be executed, but it is still not executed or provisioned. It is when we run terraform apply command. So when we run terraform apply command, these two important files are created. And since I am having the local backend, I will have these two files on my local VM. Now we have to study about the backup.state file. What is that? Sorry. Okay, it is slideshow. Now Terraform backup state file. So there are two files. One is Terraform state file, and now the second one is Terraform backup state file. So Terraform has another file called terraform.tf state.backup. This file is like a version of the state file. We have the current version of our infrastructure, and we have the previous version of the infrastructure. Now, if you know that information, I would say that it would be enough. Terraform state file is the current version of our infrastructure, and before running Terraform apply, what we had, the previous version, and that previous version of our infrastructure would be stored in our Terraform backup state file. So actually we have two versions, and that both files are updated accordingly. When we modify, our Terraform state file would be updated, and at the same time our backup terraform.tf state file will also be updated with the previous version. And we have this version so that if we want to remodify our changes, we can take a quick look and have a clear idea what we had for the last time. So the backup state file is actually the previous version of our Terraform state file. And I have mentioned here, whenever we modify something on our code and apply it, our TF state file will change our resources information. Got it? At that point, this backup file acts as an old version of the state file. So the modified resources details are in the state file, and the old TF state file will be transferred to TF state.backup file. Guys, let me explain it with a real quick example that you have done most of your times while working as a DevOps engineer. That when there is abc.conf file, okay, it's a configuration file, and you are going to modify it, what do? You take a backup of that file, abc.conf underscore bkp, right? We take the backup of important configuration files before modifying, so that we have the previous updated or working version of our important configuration file. After we take backup, then we can modify the current file, configuration file, and we can test. But if anything breaks, what we do, we just remove the current version and we rename the old version of that file, right? You have been doing this all the time while working on our Linux systems. We take the backup of our important configuration files before modifying them, and if everything or what we want to change, if it works perfectly, then we keep this file, and if something breaks, then we rename the old backup file. And that is the same thing Terraform is doing with terraform.tf state file, which is the current version of our infrastructure, and terraform.tf state.backup is actually the previous version of infrastructure. Somehow, if anything does not work as per our infrastructure, then we can simply check out the backup file and we can restore it, and we will have the correct version or the required version of our Terraform state file. So that is why both files are updated at the same time. When we modify our code, Terraform state file will be updated, and at the same time its version is maintained as a copy, which is terraform.backup.state. And you saw that we have these two files on our Linux VM. So when I am going to modify my infrastructure, then you will see that we will have updated terraform.tf state file, and we will have the previous version of our tf state file. So in the demo, I hope that it will be more clear to you. Now, Terraform backends. So there are two types of backends when we run Terraform init command, and the backends are used to store and manage the state of our infrastructure. So if we have local backend, then terraform.tf state will be on our local virtual machine where Terraform is running. And if we have remote backup, then a remote backup stores the state file in a centralized location, just like Azure Storage or Amazon S3 bucket, such as Cloud Object Storage Service or a database. So these are actually the Terraform backends. We have two types: local backend, which can be our virtual machine, and the remote backend, which can be any storage on our cloud provider. It can be Azure, GCP, or S3. But why we need remote Terraform backend? If we have the Terraform state file on our local machine, why do we need Terraform remote backend? And because it is extremely important to have a remote Terraform backend while you're working in an organization where there are a number of people working on the same infrastructure using Terraform. So we should have a remote Terraform backend. And the reason why do we have it, I have mentioned in these following 4 points. There are several remote backend providers available, such as Amazon S3, Azure Storage, Google Cloud Storage, and HashiCorp Console. And centralized storage of the state file. Remote backend is actually a central point where, just like we have Docker Hub, and what we do with Docker Hub, we store our artifacts and we store our Docker images. And why? Because those artifacts and those Docker images can be used by the team members of my company, right? That's why we have this Terraform remote backend, so that my Terraform state file can be used, can be checked by the team members of my organization. And that is why it is actually the centralized storage of the state file. We have the final version of the state file on a remote location, a storage point, and it is used to enable collaboration between team members working on the same project. So, for instance, you are working as a DevOps engineer with 10 people. Okay, it is a team of 10 people and they are working on one project, and that project is using Terraform to provision infrastructure. So, what do you say that if all these team members try modifying infrastructure, it will definitely create a mess if we do not have a centralized information point that I have to provision that infrastructure, I have to provision that thing. So without collaboration, how is it possible? That's why we need a central point where we have the state file stored. And the purpose of that central point or storage point is that all my team members must know the current state of our infrastructure. So before modifying the infrastructure, they must have a look at the state file, and this is actually the central point of our infrastructure where every information is stored. And it can be any cloud storage provider, it can be even GitHub as well, and it also has the versions of state files. As long as we are running Terraform apply, the Terraform state would be updated, and that is why that remote backend would be updated with the current and latest version of the state file. So there can be numerous and multiple versions of our state file. So it is relatively very easy for our all team members to check the state file, and they will have a clear idea of the infrastructure. And it remote Terraform backend allows us to manage and track changes to our infrastructure over time, and we have the information as long as our infrastructure grows. So it also has the history of changes in our infrastructure. How many VMs were destroyed before? How many new VMs have been provisioned today? How many storage buckets? How many load balancers, firewall rules, everything. So we have a full history of our infrastructure, and it can help with troubleshooting and auditing. Now, my fellows and DevOps enthusiasts, you can imagine the importance of Terraform state file and Terraform backup state file. So I would say that Terraform is nothing without having these state files. Without having the knowledge of our infrastructure, how we can manage our infrastructure. That is why these Terraform state files play a key role in with our infrastructure provisioning, and we can store these state files on our local VM. And when we are working as a team of DevOps engineers for an IT company, then we must have a centralized storage point where we can store our state file. And guys, these are actually the key important questions that can be asked. And guys, this is my sincere advice to know these things, to know these Terraform concepts, because you can expect everything that we discussed in today's lecture as a Terraform interview question. What is a remote backend? Why do we need a remote backend? What is a state file? How we can manage our state file if we are working as a team? What is a Terraform tfstate.backup file? So you can expect these interview questions because it is actually the Terraform core concept, and we have discussed it today in these slides. So make sure that you go through all these points, and if you still have any questions, feel free to ask me in the comments. Now, Terraform state locking. What is Terraform state locking? So you know that we have Terraform state file, but I want that state file to be locked, and it should not be modified by any of my team members. So is it possible? And yes, It is possible that multiple team members are applying different versions of the code using same state file. And state locking is for locking the state during a deployment such that no two Terraform processes try to update the same state at the same time. And it is simple and straightforward. There are two DevOps engineers, DevOps engineer 1, DevOps engineer 2, and they are working on the same project using Terraform at the same time. So when DevOps engineer 1 is going to modify infrastructure, he or she will lock the Terraform state file so that DevOps engineer 2 should not make any changes because he or she is already provisioning infrastructure using Terraform. So Terraform state locking means to lock the state file so that only one person can work on that state file at one time. If we are 20 members team of DevOps, so what would happen if everything is modifying the Terraform state file at one time? It will definitely destroy our infrastructure, or it will create a huge mess. So that is why this is actually state locking, that only one person should modify the state of Terraform while he or she is provisioning or even destroying or modifying any infrastructure. And this is known as Terraform state locking, and Terraform will lock your state for all the operations that could write the state. So none of my team members would be able to modify the state if I am the only person working on Terraform at one time. So I will lock the state file so that no one can modify the state file. And if I lock the Terraform state file, it will prevent other team members of my team from acquiring the log and potentially corrupting your state. So it will definitely help us to prevent any messes, any corruption of our infrastructure. And that is why, guys, it is recommended practice to lock the Terraform state file, and we are going to discuss it more in our upcoming lecture, that how we can lock our Terraform state file if we are using any remote backend. So I hope that now this concept is clear, that if we are a team member of multiple people and there is only one person that can work on the state file, so he or she must lock the state file so that no one from your team should change the current Terraform state file, and it will prevent the state corruption, and also it will avoid any infrastructure messing up. So that was actually the theoretical part. Now let's see how we can practically check the Terraform state file and terraform.tf state.backup files. So alright guys, now you can see I have this VM that was provisioned using Terraform, and it is DS2 V2. You can have the pricing and every information about the instances on Azure. Now DS2 V2 is actually having 2 CPUs, and it is 7 GB of RAM, and also the pricings of each instance on Azure. So I have this link, and it contains the pricing of every Azure instance on this URL. So there are actually a couple of VMs that I have been running, DS1 and DS2. Just like we have T2.micro, T2.nano on AWS. So we had standard DS2 V2, and I will see whether we have this in our main.tf file, and now I will see Control W, and so I will, yeah, the size of the VM is standard DS2 V2 according to my main.tf file, and this should be the size in our terraform.tf state file. Okay, now I can see the terraform.tf state file, and I will search for, now guys, this terraform.tf state file contains every information about our infrastructure. So it is a JSON file, and you can see we have everything here in the tf state file, and this is the current status of our infrastructure. And you can see the DevOps Molvi was the username, and this is the name, computer name, and I can search the same name here. Okay, and every information about our infrastructure. So for now I search for this standard ds2 v2, and it is actually an East Asia. We will check this as well. Control W, and all right, you can see we have this size, and our current terraform.tf state file is showing that this is the current state of our infrastructure. And for instance, if I want to check the public IP address, we have it, and I want to see whether we have this IP address here, and I will search. Okay, you can see this is the public IP address. So what we have here on our Azure cloud, the terraform.tf state has every information stored in it. This is actually about the size. Similarly, this is our release Ubuntu server, and also our virtual machine ID, and I can scroll down and we will have the information about our network as well. So I can check this, and this is actually the current version of my Terraform infrastructure. Now guys, for instance, I can take a quick look on this file. So by the way, before provisioning this VM, I had ds1 underscore v2, that the same VM I had previously. Before testing it, I was testing it for myself, so I just wanted to show you that the last version was actually ds1, and I had this version. I will just copy, Control W, and shift insert. So you can see this was actually the last version of my terraform.tf state file. Now guys, I want to downgrade this VM from ds2 to ds1 again using Terraform. Okay, so we will see, and we will compare the Terraform state files again. The terraform.tf state.backup then should have this version, and our new version would be ds1. So I will now again, I am going to downgrade this VM, and okay, so nano main.tf. So I will modify the code, and we are going to downgrade our VM from ds2 to ds1 so that we can compare the states that what we have here. And this is ds1. All right, and I will just save the file. Now I will run Terraform Init again, and now I will run Terraform plan, so to see what we are going to have in our infrastructure. Now you can see that it is saying refreshing state. It means that Terraform is having a look on the terraform.tf state file, and it is checking that what is going to be modified in our Terraform configuration file. So what is the modification? It is saying that this is going to be modified, and we had ds2 v2, and now our VM would be ds1 v2. Okay, and after we run Terraform plan, after we run Terraform apply, our VM would be downgraded from ds2 v2 to ds1 v2. Currently we have DS2 v2. Okay, and now I am downgrading my VM from DS2 to v2. So that is why I have modified main.tf file for configuration. Let me show you again so that sorry, now we have DS1 v2. We are actually downgrading. So Terraform plan showed us that this is the change being going to be happening. And now I will run Terraform apply, and both our terraform.tf state file and terraform.tf state.backup file would be updated accordingly. So before watching the output, I would request you to let me know in the comments what would be that change. What is going to be changed in terraform.tf state and what is going to be changed in terraform.tf state.backup file. I'm going to run terraform apply, and our VM would be downgraded, and you can see it is saying Terraform is refreshing the state. And what is going to be changed? This is the change. Are you agree? Yes, I'm agreed. And now there is nothing to add, only one change, and there is nothing to be destroyed. What is that change? The VM is going to be modified, and it is downgraded from DS2 v2 to DS1 v2. So it will take a couple of moments, and that would be actually our last step of today's lecture. And this is something really interesting. That is why I encourage you to try it again and again and again so that you get your hands on Terraform. And guys, you can see the apply has been completed, only one change. So I will refresh and my VM should be DS1 v2. Now you can see we have downgraded our VM, and now it is standard DS1 v2. And also now we have to check our terraform.tf state file, and I will check terraform.tf state, and it should have Terraform standard DS1 v2. Control W, I will just copy it. Sorry, I will copy, and now we should have this in our okay, and our terraform.tf-state.backup file should have standard DS2 v2. Okay, before opening we should be sure about the change. So terraform.tf-state.backup should be have the previous version of our infrastructure. So the previous version was actually standard DS2 v2, right? Are you getting? So now I will check terraform.tf-state.backup, and it should have Control W, and I will shift insert. I cannot find this DS1 v2, but I should find shift insert, and the previous was actually DS2. So that's it, guys. You can see the previous size of our that VM was actually DS2 v2, and now since we have downgraded, so we have now DS1 v2. So our current TF state file has this version, and this is actually the current version of our terraform.tf state, and it matches with the current state of our infrastructure. And oh sorry, Control X, I will reopen it, nano dot Control W, shift insert, and oh sorry, again Control X, nano terraform.tf state file. I will recopy it from here, sorry about that, and I will search for it, and it has the current state of our infrastructure. So that was the quickest demonstration about the difference between terraform.tf state file. You saw that how Terraform maintains its state, current state, and also you saw that we have the backup or an older version of our current state. And in the next lecture, we are also going to talk about the remote backend, how we can configure a remote backend on Azure, and then we will have a quick lecture on Terraform modules as well. And finally, our series of Terraform will end up with Terraform interview questions and answers. So far we have covered what is Terraform and how Terraform works. We had two amazing labs on Azure and Google Cloud Platform. Today we discussed the core and the most important concepts of Terraform state file, state locking, Terraform state backup file, and you saw how these are managed by Terraform, and we had actually a demonstration here. So make sure that you subscribe DevOps Molvi. We are going to have more fun with Terraform, and Terraform is one of the most important tools that is asked about in every DevOps interview and every DevOps job. So make sure that you watch all these Terraform lectures, and still if you have any questions, feel free to let me know and I will answer all those questions. And thank you so much for your appreciation and support. I will see you in the next lecture. Have a good one. Take care and bye. Hey guys, I hope you're doing great today. Well, today is an important lab in which we are going to configure a remote backup for our Terraform state file. Guys, in the last lecture, if you have watched it, we discussed about what is a Terraform state file and what is a Terraform state file backup. Okay, there were two files when we saw that when we applied Terraform apply, we had two files, terraform.tf state, which contains every information about our current running infrastructure, and we have a previous version of that terraform.tf state file, which is terraform.tf state.backup file. So we saw that those files were updated when we made some changes in our infrastructure. So when we run terraform init command, you saw that there was a message printed or shown by Terraform that Terraform is initializing a local backend. Okay, now that local backend is actually the backend of our VM, where our terraform.tf state file is located. So after that, we also discussed about the two types of backends. Local backend, if we are having our terraform.tf state file locally on our VM, then this is actually our Terraform local backend. But if we are having terraform.tf state file on any of the cloud providers in storage bucket like S3, or in a blob container on Azure, or in GCP storage, then this is actually our remote backend. And also we discussed why do we need a remote backup, because in local backend, when I'm the only person who is managing the infrastructure, then I can have a single terraform.tf state file locally on my virtual machine. But what if we are a team of 10 or 20 DevOps engineers and they are working on the same infrastructure? So definitely we should have our terraform.tf state file on a remote location, so it is accessible or everyone can manage or see what infrastructure we are having. And that is actually the purpose of configuring a remote backup to store our terraform.tf state file on a remote location, which can be accessed by our DevOps team members and anytime. And it is really easy to configure a remote backend. But if you have not watched my previous lecture, it is really important. If you understand what is the purpose of Terraform state file and Terraform.tf state.backend file, then this would be more easy for you to understand real quick why do we need to configure a remote backend. And I have, by the way, shared everything on our Terraform by DevOps Molvi repository, which contains every lab and configuration file we have done so far. So make sure that you should take a fork, and you must have it so that you can practically perform what we are doing here in our lab sessions. So you can see we have Azure. I have opened it here, and this was actually our first lab in which our infrastructure was provisioned on Azure, right? And also I have told you guys how we can install Azure CLI on a Linux Ubuntu machine. After that, we logged in using our Azure CLI running az login command, and we created a free subscription. And also every detail is, by the way, mentioned in this file. Now today we are going to configure remote backend, where we are going to store our Terraform.tf state file on Azure storage in a blob container. So I have created two separate files in this folder, remote backend configuration, which is here. All right. So I have opened everything in separate tabs to make it more convenient for you, so that you can easily know where are we headed. And now there are actually two files, Terraform configuration files here, main.tf and storage.tf, and we are going to work on both files. The main.tf file is actually the same file that we had in our first lecture, and it contains the resources that we provisioned on our first lab, in which we had 6 resources, including a resource group, a virtual network, and a private subnet, a public IP address, and a virtual machine on our Azure platform. Now, when we are doing that lab, we were having our terraform.tf state file on our local VM. I can show you here. You can see now we had terraform.tf state and backup files on our local VM. But what now, the important thing is that I want to have my this terraform.tf state file, which is the core of our infrastructure, on a remote location on my Azure cloud, or it can be your AWS S3 bucket, or it can be a GCP Google Cloud Platform bucket. But today we are going to perform this lab with Azure, and it is your choice if you want to have if you want to use AWS S3 bucket, which I will try my best to cover in the future lecture. But today the main purpose is to understand what is the purpose of a remote backend and how we can configure a remote backend using Azure. So there are actually two Terraform files, main.tf and storage.tf. So you don't have to confuse that. What is the purpose of storage.tf and main.tf? The main.tf file is the same file we had in our first lecture, in which we provision a virtual machine with its prerequisites, okay, network, etc., firewall. Now we have to modify it more for our remote backend configuration. Now I don't want terraform.tf state file to be created on my VM. Instead, it should be on my Azure cloud. So now we need to study about the configuration, additional configuration that we have to do in our main.tf file. So there are actually two Terraform configuration files, main.tf, and this is the second file, and I will tell you why I created this story.tf file. The purpose of this file is to create a new storage account and a new storage container on Azure, so that we can see what changes are occurring when we run Terraform init and Terraform apply command with the terraform.tf state file. So you will definitely get what's the purpose of both files. So first of all, we need to discuss about the Terraform main.tf configuration file. So you can see this is our main.tf file, and if I have a quick review, hold on, I will zoom it, and now you can see we are having our provider as azurerm, the subscription client ID, client secret, and tenant ID. We have discussed in our first lab, and we are creating a resource group, a virtual network. These are actually the prerequisites. These resources are required by the VM, and a public IP address which was attached with our VM using this network interface card, and this is how we have configured our IP address. And after that, we created a virtual machine, only one resource, only one virtual machine using this main.tf file, and I was having everything in a single main.tf configuration file. Now you can see we created this DevOps Molvi Linux VM. So I would strongly recommend that you must run this configuration file on your VM, so that you can see how we can provision infrastructure on Azure using Terraform. Now guys, today we are starting from this point, okay, and I have updated the same main.tf file and modified it for the remote backend configuration. You can see we have Terraform remote backend configuration, and there are actually 4 more steps that we should perform, so that we can easily configure our remote backend for our terraform.tf state file. So we need a resource group, okay. Now a new resource group would be created with this name, backend underscore rg, means resource group, and I have named it as DevOps Molvi backend rg. This is my resource group, and the same location that we had while we created our virtual machine, and it is East Asia. This is the location, and where our storage account will be created, where our blob container will be created. So this is actually the location, and you can have East US or the location of your choice. Now we are creating a storage account for our terraform.tf state file. Terraform.tf state file is a JSON file. I hope that you haven't forgot every concept that we have already covered so far. So terraform.tf state file is actually a JSON format file, okay. So we have our infrastructure information in a JSON format in our terraform.tf state file. So this is actually the storage account, SA storage account for our terraform.tf state file. So we must have a storage account, and its name is DevOps Molvi storage. I have given this name, and remember that it should be globally unique, okay. Just like if we have a storage bucket on Google Cloud Platform or storage bucket on S3, their names must be globally unique. So I have this DevOps Molvi storage, and this is actually the resource group name, backend underscore rg, and it will take the name from here, and this would be our DevOps Molvi Backend RG, our resource group name. And this is my location, which is East Asia. Okay, these are variables, and we are getting their values from here. And now account tier, just like we have the account storage account types. Okay, storage types, which is standard, and LRS stands for locally redundant storage, LRS, which is the storage type in Azure. So this is my account replication type, locally redundant storage. Now a blob container in Azure is just like a bucket. Okay, a bucket where we have to actually store our terraform.tf state file. So it is actually a blob container. If you have worked on Azure, you must know that. So a blob container will have a terraform.tf state file, and this is actually the container name and the name of the file. Okay, that sorry, this is the name of the blob container tf state, or I can have it DevOps Molvi tf state. So this is actually the name. You can have the names of your choice. Okay, so don't worry about the naming conventions. And this is my account storage name. So account storage name, you can have it from here. This is actually the DevOps Molvi storage, which is my storage account name, and it is actually private. You can have it publicly available, but now for security reasons, I will set it to private, since our terraform.tf state file contains every information about our infrastructure. It can have our, so it must be private. Now here, actually, in the last step, we are configuring a remote backend. Since we have everything ready, we have all the prerequisites, we have a resource group, we have a storage account, we have a blob container. Three things: storage account, a resource group, a storage account, a blob container. And that blob container will have a terraform.tf state file. So now we have created a resource group, we have created a storage account, and now we will have our blob container, which will contain our terraform.tf state file. And this is the resource group name. This is my DevOps Molvi storage as storage account name. Container name, just like we had in while we were creating blob container tf state, and this is actually the key file. All right, so when we will run terraform init, terraform plan, and terraform apply commands, it must create a resource group. This would be, it will create a resource group DevOps Molvi Backend RG, and then it must create a DevOps Molvi storage account. And after that, it should create a container named tf state, and that container must have a terraform.tf state file. So that's how our backend configuration will be complete. So let's try it out. And I have this main.tf file, and if I edit it main.tf, and I have all the configuration just like we have in our GitHub repository. So you don't have to worry about just take the clone or just copy the content of the file, and you can run it on your local VM, a Linux VM. So everything is ready. We just have to run Terraform commands so that we can have a storage account, and our backend configuration must be completed for our terraform.tf state file, just to show you that we don't have any storage account on my this Azure account. Okay, so we are going to have it created from scratch. I don't have any storage account in the storage browser on Azure. So you can see that I have this terraform.tf state file on my local machine. This is my local VM, and I have this terraform.tf state file. So it means that it is my local backend. But now we are going to shift our local backend to the remote backend. So we will have our terraform.tf state on our Azure cloud in a storage. There would be a storage resource that we create and a blob container which will contain our tf state file. So first of all, what I will do is that you can copy the code from here. I'm sorry, I have everything in the same main.tf file. I will copy this code, and I'm not adding this block. I will add it at the end. Due to some issues, I will add this block at the end after creating the other required resources. So I will add it main.tf, and I will add shift insert. And now what we are doing, we are adding a resource group for the backend storage account, a Terraform storage account for TF state, and a blob container. So for now, I will run Terraform init, and you can see we still have the local backend. This is initializing the backend, means that it is initializing the local backend. Now I will run Terraform plan. Now you can see that it is going to add 9 resources. So if you can count all these resources, we had 6 resources from our VM, and therefore these 3 additional resources will be added to our Terraform plan. And now I will run Terraform apply, so that we have a resource group created for our storage, a storage account, and a blob container. And after that, I will add the code where we will have actually the backend configuration. Now I will enter yes, and it will add these 9 resources. So I destroyed everything, and now I am recreating the infrastructure again. So you can see it is creating the virtual machine. Now we are having our storage account created, and now our storage account will be created, and after that we will create a blob container. So it will take a couple of moments, and Terraform apply takes time because it is actually provisioning infrastructure on the cloud. So we have to be patient. And now you can see apply has been completed and 9 resources have been added. So still we have our backend on this machine, okay, on my local machine. So now I will add this code. Actually, this code block is the main configuration for our remote backend. So you can see that we have created the resource group, we have created the storage account, we have created the blob container. Now it will contain our terraform.tf state file, right? So I will add this code in my main.tf file, and again we will run shift insert. So now I will initialize my Terraform, okay, clear. I will initialize to see whether our backend is going to be shifted from local to the remote, and initializing the backend. Now this was actually the main point that I wanted to show you. It is saying that, do you want to copy existing state to the new backend? Of course we want. We are shifting our local backend to our Azure cloud, and pre-existing state was found because we have a terraform.tf state file on our virtual machine, and while migrating the previous local backend to the newly configured azurerm backend, Okay, now this is the actually our remote backend, which is azurerm backend. No existing state was found in the newly configured azurerm backend. So no existing state was found in the newly configured azurerm backend. Do you want to copy this state to the new azurerm backend? Enter yes to copy and no to start with an empty state. So I will enter yes, and then we will be able to see our terraform.tf state file emptied on our local VM on this virtual machine, and we will have our terraform.tf state file migrated to Azure. Now I will enter yes, and you can see successfully configured the backend azurerm. Guys, that was actually the thing that we wanted. We have actually successfully configured our backend azurerm. Terraform will automatically use this backend unless the backend configuration changes. Now our terraform.tf state file, every time if we provision new resources, that file will be actually updated, and we will have our terraform.tf state file on our Azure. I will actually show you, but after we have it, a Terraform plan, we will run Terraform plan to see what output we have, since most of the resources have already been provisioned, and now it is refreshing state. So it is saying that no changes, your infrastructure matches the configuration. And now I will run Terraform apply to see if anything new is happening. Since we have everything, we just changed the remote backend. We changed from locally to remotely, and it is saying that no changes, your infrastructure matches the configuration. Terraform has compared your real infrastructure against configuration and found no differences, so no changes are needed. Apply complete, and now we will be able to see whether we have our terraform.tf state file created on Azure. So I will go to the resources. By the way, you can see DevOps Molvi backend resource group. It has already been created. Now it should have a storage account. We can see DevOps Molvi storage as per our main.tf file. If I open my main.tf file, and if you can see, this is actually our storage account name, and we have it. Now you can see we have this storage browser, and it should have a blob container. Now there is a blob container tf state. Okay, this is actually the tf state, and this is the container name. Okay, I have this for my terraform.tf state file, I have this container name, and in this container we are having our terraform.tf state file. And if I want to download it, we can download it. You can see I have this terraform.tf state file, and if I want to edit it, now you can see we will have everything on our Azure backend, and this is our remote backend. And now I can share this terraform.tf state file with my team members as well. So it contains our virtual network and storage account, etc. So guys, that's how we can configure our remote backend. Now for your further learning, I have created this storage account. Okay, and this is just to get your hands on Terraform. You can add more resources and check the state file in Azure for the changes every time we create new resources. After all, we are going to provision more resources on Terraform. That's why we have to compare if that terraform.tf state file is getting updated each time. So I can simply copy this file. So there is not much huge going on. I'm just creating another storage account, SA2 DevOps Data 2, and I'm creating another blob container. So let's try it out and see what we get. I will create nano storage.tf, storage.tf, and I will just paste this file, and Now I will initialize Terraform init. Backend has been initialized. Now it means that this is our Azure M backend. So I will run Terraform plan and we'll see what we have additional resources, and then we will compare our terraform.tf state file on Azure. So you can see we are adding 3 more resources: a resource group, storage account, and a blob container. And I will run Terraform apply, and it should not take much time because we are only provisioning 3 new resources. So every time it refreshes the state, that is why, oh sorry, apply has been cancelled. I will run again. I will enter yes and see if we get another blob container. Now it is creating a new blob container, and it will not take that much time. And another storage account is also being created. You can see we have to be patient while running Terraform apply, since I told you that it takes some time. And now storage account 2 is being created, and a blob container will be created as well. So 3 are being added. So it means 1 new resource group, 1 new storage account, and 1 new blob container. So it has been completed. Apply complete. 3 resources have been added. So guys, now you can see we have a new resource group. Okay, this is my new resource group as per my story.tf. Let me open it, story.tf. And we have this DevOps Molvi resource group, new resource. We have this DevOps data 2. And you can also see from your dashboard that DevOps data 2, that storage account has also been created. I will just open it in a new tab. But the most important thing that we must see is to see the changes in our terraform.tf state file. And I will go to the DevOps Molvi storage, and I will open the storage browser, and I have this terraform.tf state file. So I will just download it. So I have opened it, and now if I want to search for this container, new storage account, and this blob container to see whether we have it or not. And you can see we have this new blob container. Similarly, if I want to search for the new storage account, we should have it in our terraform.tf state file. So guys, that was actually an amazing thing. I was super excited to share that how terraform.tf state works remotely. We have everything updated on our Azure storage account. So that's it guys. That was actually our practical session in which we actually configured our remote Azure backend. So you can find the remote backend configuration on this repository. I have already shared this repository URL. I will add this repository link into the description. If you just want to configure the remote backend, you can try it out. You just have to update your main.tf file accordingly, or you can just copy paste on your machine and you can run Terraform commands. But the main thing that you must understand it is how it is done. So I have already put the comments and I have described what's going on each resource. So the storage.tf file is just as additional file. So you can configure more resources and check your terraform.tf state file whether it is having new additional changes. So we actually practically saw everything in this lab. So make sure that you must try, you must work on it, and you must provision, and you must have a new remote backend instead of a local backend. So that is actually a really important lab that you must do it on your machines. I would strongly recommend that. I will see you in the next video. Make sure to subscribe DevOps Molvi on YouTube. We are going to hit 1K. So have a good one. Take care and bye. Hey guys, I hope you're doing great today. Well, our journey with Terraform learning is going great so far. And today we are going to discuss and we are going to learn about Terraform modules. You guys know that I have created this repository, Terraform by DevOps Molvi, and in which we have been sharing together everything that we have worked so far. So we have covered Lab 2, we have also covered infrastructure provisioning on Azure and GCP. Today we are going to talk and learn how modules work in Terraform. So I have created this separate new directory, Terraform modules by DevOps Molvi, and since I'm sharing this repository URL in the description of every video so far, so make sure to check out the description and you will find this repository link. It is a public repository. So let's get started with Terraform modules. And I have this Terraform modules directory, but first we must know what is a Terraform module. Guys, the simplest definition of Terraform module is that a set of configuration files in a single directory is a module. Okay, I have a directory and I have only one main.tf file, then it is a module. Now further, if we explain it further, and we will definitely see how modules work in Terraform, you can see that I have this directory infrastructure, and now this directory contains 4 more directories, and the purpose of Terraform modules is to reuse for our infrastructure provisioning. I will use that code again and again. I will reuse actually, so that I can provision infrastructure, and that's the purpose of Terraform modules. When you have to reuse the code, this is actually Terraform moduling. This process is actually known as Terraform modules, or we can create Terraform modules ourselves, and we can also use the Terraform modules that are provided officially from the Terraform registry. So for learning our own learning and knowing Terraform modules more better, I have created this lab, and in which we have these 4 directories. Now guys, for your understanding, these are 4 Terraform modules, okay, and these are actually child modules. Why these are child modules? Because I will run Terraform commands from this directory, which is my parent directory, Terraform modules by DevOps Molvi. I can show you from here, ls-l, and I have this Terraform modules by DevOps Molvi, and you can see I have a main.tf file here as well, and I have infrastructure directory. Now this would be considered as the root module, because I will run Terraform commands in front of you from this directory, okay, and I have this main.tf file, and this main.tf file actually has every information for the child module, okay, and I will run, you can see I have terraform.tf state file and terraform.tf state.backup files in this directory, which is Terraform modules by DevOps Molvi directory. So we can say that this is actually a a root module. And in infra we have these 4 directories. These are actually considered as our child modules. And when I run Terraform command, what will happen? We are going to create 3 VMs, okay, for our development environment, and we are going to create a storage account and a blob container. So that is the purpose of modules. Instead of having one main.tf, one variables.tf file, and one outputs.tf file, provider.tf file in one directory, it can become so complex, and it would be really hard for a DevOps engineer to organize that infrastructure. So that is actually the purpose of creating separate Terraform modules. Now each directory should contain a main.tf file. Okay, and these directories are, I'm repeating again and again, these directories are actually considered as child module. And why these are child module? Because I will not run Terraform commands from these directories. Each directory has Terraform configuration files, but I will run my Terraform commands from here, which should be considered as our root module. Okay, now you must understand the difference between a root module and a child module. The folder or a directory from where you're running Terraform commands is considered as the root module, and the other folders which have the configuration files to provision infrastructure are known as child module. Okay, now I hope that you understand the difference between a root module and a child module. Now this directory infra contains 4 more directories. Okay, and now each directory has a main.tf file, you can see, an outputs.tf file, and a variables.tf file. So each of these modules is actually managed by the main.tf file, which is the root module. So first of all, we have to go through this main.tf file, and now you will see, let me open another tab so that I will have a duplicate, and this is our infrastructure folder, and for instance I'm starting with VM1. Okay, and VM1 has these configuration files to provision a virtual machine on Azure. So now you can see the same practice that we have done so far. Okay, while provisioning infrastructure, provisioning VMs and storage accounts. If you have watched my earlier labs, you must know about provider and these subscription IDs, client ID. We have to create a principal, and we have to paste our subscription ID, client secret, and tenant IDs here, so that our Terraform can talk to our cloud, Azure cloud, to provision infrastructure. Now guys, this is actually my first module, and this is VM1. If you understand this one, then the rest of the configuration and the rest of the modules are totally same. Okay, so you have to understand this one. So now you can see we have the module information here. Okay, now it will create a virtual machine, and the virtual machine name would be DevOps Molvi 1 VM. Similarly, the other VMs have DevOps Molvi 2, and this one has the DevOps Molvi 3 VM. All right, this one. So first of all, you can see I have given every required information about my virtual machine 1, and this module will use this directory VM1, which is a child module, to provision virtual machine on Azure. Now you can see we have source. Where is the source? We have the source from here in infra VM1. Now you can see I have this source, and this is actually the syntax to give the source information from where our root module will get all the values to provision a virtual machine, and this would be our source, and every information in that source should be given so that we get no issues while provisioning our virtual machine. And now you can see we have the source VM1, which contains our variables.tf, outputs.tf, and main.tf file. Now I have resource group name, location, virtual net, subnet name, virtual machine size, and this would be the username and password for SSH access. Okay, for SSH, and this is the image publisher, and we will have 3 virtual machines with 18.04 long-term support Ubuntu release installed on each, and the tag of each virtual machine would be environment, because these are created for dev1 environment. So each virtual machine will have this tag. Okay, now you can see the other virtual machines have the same specs and everything is almost the same. Instead, the source of the rest of the virtual machine would be different, because now you can see the virtual machine 2, which is our second module, and it has this source VM2, and we have this VM2 as well. You can see VM2, similarly we have VM3, and similarly we have for storage for our storage account. And now you can see rest of the values are same, because I'm creating my infrastructure in a single region, which is East Asia, under one resource group. So I don't want to create a huge mess creating separate resource groups, separate regions, etc. So I want that my virtual machines and my storage are in the same resource group and in the same region. So it will, I mean, it is easy to organize. It is better to understand what we have in which region and in which resource group. So we have this one virtual network, we have the same subnet, and similarly the virtual machine names would be different, right? So from that perspective, I have three virtual machine names: DevOps Molvi 1, 2, 3 virtual machines. And I can have the same password for our virtual machines. All three virtual machines can have one password, similar password. Now it is up to you. So this would be my admin username, which will be a sudo user, and I will have the password, and release and version of the operating system would be the same. Similarly, we have this module, our third module, VM3, and I have the source here, VM3, and you can see we have the same resource group, East Asia, and the rest of the information is almost the same. This is just the duplicate copies. Okay, now I hope that you can understand it better. If you can create one virtual machine, it would be easy to reuse that code for creating other machines. Now I can use the same code to provision 10 or 20 or 30 machines, right? This would be the major advantage of Terraform modules. We are reusing code. That code is being reused to provision our infrastructure, which is the core concept of Terraform modules. To reuse code. Okay, I hope that now you understand it better, because we have one virtual machine and that same code is reused for provisioning other two virtual machine, except for changing the major information like the source of the child module and the name of the virtual machine name. So it will create an error that the virtual machine with that name already exists. So that is why I'm creating three virtual machine with three different names, right? And this username and password, I have kept it the same username and same password, so you can have different as per your choice, and the release and operating system version is the same. Now guys, the last module is our storage module, and you can see we have this source of that module, and I have this storage here, and it will create you can see it will create a storage account and a blob container, just like we did in our previous lecture as well. We are going to create a storage account in East Asia, and the storage account name would be DevOps Molvi storage, and the blob container, which will contain our files and our data, and it will be DevOps Molvi. So this would be our container name. Okay, so I have these four. So guys, Terraform by DevOps Molvi, you can go here and you can find Terraform modules by DevOps Molvi and this main.tf file. Okay, so I would recommend that when you clone this repository, you must change the values so that you can better understand how the infrastructure is being provisioned. All right, so this was actually our root module, and this directory infra contains the information about our child modules. Okay, so first of all, if I go to the storage module, it contains a main.tf file, and we have the information about our resource group. Okay, this is our resource, and var.resource group name. Okay, and I have this variables.tf as well, from where we are getting our variables. So similarly, we have the storage account. That is actually the same practice, and I hope that you know about these code blocks, what are we doing in each code block. So I will not going to repeat it, since we have already done it multiple times, but just sharing the overview that what's going on in each module. And you can see we have this container. Now I have this var.container name, so we must have a variables.tf file, you can see here, and every variable is given here: container name, storage account name, location, resource group name, and each variable will have the values taken from here. Okay, you can see we have var.resource group name, so it would be DevOps Molvi resource group. We have var.location, the location will be East Asia. Similarly, we have var.storage account name. All right, so we are having the values here, and all these values are being used by these child modules in storage. And similarly, if we go to infrastructure, we have the VM1, and if you understand how VM1 is being provisioned, you will be able to understand the rest of the virtual machines. So it also has a main.tf file which contains the resources that we are going to provision. Okay, for each virtual machine we will have these resources. The resource group will be same for all these three machines and the storage account. So we will be having only one resource group. We can see the resource group here as well. So after provisioning the infrastructure, we are going to see the resource group here. So we will definitely check it in a couple of moments, and we will have a virtual network for 3 virtual machines. We will have the subnet, and guys, make sure that we can have the different address prefixes to avoid any conflict. Okay, I will have the different address prefixes and the network interface card for public IP addresses, and this is actually the resource block for provisioning our virtual machine. And every information we have, like if I talk about var.vm underscore size, so we must have this. You can see VM size should be standard v1s, so it is the same size for all the rest of the VMs. And we have the OS disk, and it is actually standard locally redundant storage for all the rest of the virtual machines. And similarly, we have tags, var.tags, and each virtual machine will have the tag as the dev virtual machine. This would be the tag, and each virtual machine is a dev machine. So guys, this is the main.tf for our virtual machine 1. Similarly, we have the main.tf file for virtual machine 2 and virtual machine 3. Okay, if you want to see, I can go to infra, and we can have a look on VM2. You can see we have configuration files for VM2. Now these are modules. Okay, these are Terraform modules because we are having Terraform configuration files in a separate dedicated directory. This is what a Terraform module is. And similarly, we have the outputs.tf, and we have the variables.tf file for all the rest of the virtual machines. And what is the purpose of outputs.tf? The purpose of outputs.tf file is to share the data among different modules. So that is why you will see the outputs.tf file in each module. You can say that outputs.tf file is used for sharing the data between the root module and the child modules. So that is the purpose of outputs.tf. And similarly, if we want to declare the variables, we have this variables.tf file, and it contains the information like resource group variable and their type, location variable and its type, and VNet variables. And all these variables are used in our main.tf file in each module. So you can see we are using these variables in our main.tf file. So guys, that was actually an overview how modules work. And you can see I have this dedicated directory created with a root module, and we can see we have 3 virtual machines and a storage that we are going to configure, that we are going to provision using Terraform. So you can take the clone of this repository, and then you can try at your virtual machine and make sure that you have created a principal, and you need subscription IDs, and these rest of the all IDs should be there in your main.tf file. So you need a principal first created, and make sure that you must give the subscription IDs and the rest of the client ID and tenant ID and client secrets here, so that you do not face any issue while running Terraform commands. All right guys, now let's see what we have here. I have the same configuration, same folders, same directory structure, same modules, and a root module here. So I will be running my Terraform commands from here. This is our main.tf, and similarly we have this infra directory, and it contains our child modules. So let's run and see what we get. Okay, so I will clear it, and let's change the settings. This font is a little bigger and I have to change it. Okay, so I hope that you might able to see it as well. Now I will run Terraform init command. Okay, initializing the backend and initializing modules. Okay, you can see our modules have been initialized. Now I will run Terraform plan, and it will share a huge output. That is actually a huge output, because we are going to create almost 15 plus resources, and let's see how many in total we are going to provision while running Terraform plan. All right. Okay, now you can see the plan is to add 18 resources, and we are going to change 0 and 0 to destroy. So everything is going to be a provision from scratch. So in total we are going to add 18 resources. And if I have a quick look on our Terraform plan, then you can see it is saying that refreshing state. Guys, I am having my terraform.tf state locally on my virtual machine, since it is just a dev environment. And note, objects have changed outside of Terraform. Terraform detected the following changes made outside of Terraform. Okay, so since I have been working on this directory, I have been provisioning virtual machines and storage account. So you may not get this message or note, but since I have been working for the last couple of hours, so that is why these are, guys, the modules. Okay, and now Terraform will use the selected providers to generate the following execution plan. Now this is actually our module information. This would be our storage module, and this would be our account storage, the information about our account storage, and similarly our virtual machine 1, our second module, the information about our virtual machine resource group, subnet, and this is actually the virtual machine. Now you can see we have this name virtual machine 1 for our VM1, and similarly we have the rest of the modules for our virtual machine 2. Okay, this is our second module, and similarly we will have the name here. Guys, this is just a plain JSON file, so I hope that you don't have any issues while reading this JSON. And similarly you can now see we have this DevOps Molvi 2. This would be our third virtual machine, and it is our third module, and every information we have here: resource group, subnet, and virtual machine, VNet, virtual network, and OS profile, storage, data disk, release, everything in Terraform plan. So now we are going to run Terraform apply, and that Terraform apply is going to take some time because we are going to provision 18 resources. So I will run Terraform apply and auto approve. Okay, auto approve, and I don't have to give yes when it asks, and it is actually auto approved. So now take some rest, and we will see how much time will it take to provision our virtual machine. So it has been started. Okay, and now you can see the virtual machine resource group is going to be created, and similarly our modules are in the process of creation. So I will sit back and see. So by the way, Terraform apply is you can say that it is the real-time logs of your infrastructure. You can see the real-time logs, what your infrastructure, how it is being provisioned. So these are actually, I would say that these are logs or the information about how our infrastructure is being created. You can see still creating, and some are creation complete after 18 seconds. So that's how Terraform apply shows us the real-time information. Alright guys, Terraform apply has been completed, and you can see we have our DevOps resource group. So we have every information. Now you can see we have the DevOps Molvi storage account. For instance, if I open it in a separate VM, we have the virtual machine 2, virtual machine 3, and for instance, if I click on this virtual machine just to see how and you can see it is already in running state, we have the size here, and in a moment I hope that we get the rest of the information. I will just refresh it, and we will get the public IP address and the time created here. So this is our storage, DevOps Molvi storage account, and I will just refresh it again. So you can see we have this storage. Okay, as per our infrastructure, we have this storage infra, and we have a storage module, and here we can see the resource group and our storage. It is all LRS, locally redundant storage, and we have a blob container as well. So if I click on blob container, it should have one container created. And similarly, if I go to my DevOps Molvi resource group, the rest of the provisioned resources, we can see all of them in this one resource group. Okay, so you can see every resource has one region, and each DevOps Molvi 2 VM, 3 VM, similarly we have 1 VM, and this is, you can see the storage, and we have this blob container which should be empty because we don't have any data. But you can see our modules have been provisioned. We have our infrastructure, and we use Terraform modules to build all of these, and we have disk network interface cards in each in one location. Okay, and we have virtual machine NIC network interface cards as well. So for instance, if I go to DevOps Molvi 3, so these are actually the separate 3 virtual machines, right? And every virtual machine is running in East Asia region. So guys, that's how we can use Terraform modules. So I will definitely share the repository URL. So you must clone it and you must run it on your virtual machine, and you will see the magic. You will see your virtual machine storage account and every. You can add more virtual machines. You can add more storage accounts in this configuration. You must modify it. This was just an overview how Terraform modules work, and I hope that you have enjoyed this virtual lab with me. So I will definitely share more about Terraform in the upcoming lecture. We are going to discuss about Terraform interview questions and answers. So make sure that you subscribe DevOps Molvi. I will watch you in the next video. Have a good one. Bye.